Okay.
Fuck.
How are you going to wrap all that up? Good luck.
We can't.
So hard yarners, I have no idea what
they're coming in for. Yeah.
No, what are we like?
Okay, we start. My brain is fucked.
Is broken. You're gonna have to listen to this a couple of times.
I got veins on the fucking veins that I didn't even know.
Yeah, you were actually really flabbergasted. I couldn't believe. I'm just going to put my hand up. I had a bit of knowledge that I forgot about. I thought it was all right. But
so we are here with Dr. Robin Cook,
astrophysicist,
young strapping scientist. Briefly, a brief summary of time. What's Stephen? Give us a brief history of the pod.
Reading of the entire brief history of time. Yeah.
Yeah. What did we chat about?
Oh, we talked about anything, right? Everything and anything. Anything that wasn't on this planet, I think we talked about, right?
Yeah.
Actually, we did talk about a few things on the planet.
Yeah. We talked about
right.
black holes. Your role in the new radio telescope. Which one?
The array, the square kilometre array.
As well.
And the
James
James
Webb Space Telescope and the Hubble Space Telescope.
And how it works. I still have more questions about it.
Time bending.
A bit of interstellar kind of.
Non-binary and binary identifying fucking star systems.
Universe is very woke.
Donald Trump naming everything.
Mate. Incredible.
Yeah. This is very informative. We're sort of like...
I didn't even ask about Europa. I wanted to ask about Europa. Anyway, you're coming back. We need to get you covered.
We went like an inch long and a mile wide today.
Yeah.
So we'll have to go deeper or just keep going at that inch.
Wait until we start talking about Uranus and everything.
I'll need a few inches in there.
Yeah.
Perfect.
All right, let's get hard.
Welcome to Hard Yarns Podcast.
I am fucking fat.
Anything Chris White says, please disregard it.
5D is actually a state of being. It's a unity consciousness.
That was Hard Yarns with me, Frankie Rose. So I'm going to throw it over to your co-hosts,
Daniel Delby.
And Cameron Brand.
I would do this and then I'd gong.
Free in attendance.
Are they all down?
For the millions listening at home. Let's get hard.
Where do you want to end up borrowing this space out? Like, turn it into a podcast studio, photo studio, office space.
Yeah.
It's fucking cool. Like, it smells a bit from a party we had here.
Noticing a black couch in the corner there too. No questions asked.
Well, that's
casting couch.
Yeah, I was gonna say you just skip the normal process.
Get all the formalities out of the way.
Yeah. So this is exciting for me, and I think Delby as well. But
I like learning.
This is such a topic I know absolutely nothing about, but also I'm so interested about.
Yeah.
So
who isn't?
Yeah.
It's pretty good. We get straight into it, mate.
Yeah,
so
absolutely.
Cool.
Crack on.
We don't even do an intro. We do that in post. So let's start with what you
doctorate.
Who you are and what your sort of credentials are.
Yeah, right. Dr. Robin Cook. Doctor meaning I've spent a long time of my life studying to do what I do. 7.5 years at university studying astrophysics. So I'm a astrophysicist. That means I'm a physicist, so I try to understand things around us and things in the world, right?
Yep.
And the astro part is that anything not on this planet, that's what I'm interested in.
Fuck, that's where I was yesterday.
Yeah, on another dimension.
Yeah.
So
No, this is day after Melbourne Cup, people listening, so I'm feeling like a Norm Smith medalist right now. I'm dusty as fuck.
Well, we've been talking recently about guests that we want to get on and topics we're interested in. We keep on saying we want to get an astrophysicist on and talk that. And then Delby mentioned that you made comment on the new telescope.
Yeah, right. The James Webb Space Telescope.
Yeah.
And I looked at the new resolution of I think it's the Pillars of Creation, I think. And mate,
they're incredible.
Unbelievable. And I thought that was my favourite picture, and I don't know how many people have a favourite picture of a galaxy, but I do. That was always the thing that I remember seeing it in a book growing up my dad had, and just thought that's incredible. Yeah, and now seeing it in such more detail.
That's it. And we've got beautiful images of the Pillars of Creation, the Eagle Nebula from like the Hubble Space Telescope, and that thing itself was, an incredible machine that was done, 20 to 30 years ago. And when those images came out, people were like blown away by the quality of the data. And now you look at it in comparison, you're like, geez, that was like a crummy old film.
It's a blurry almost.
Yeah, it's blurry. And the amount of detail that comes out in this James Webb Space Telescope is just incredible. It's not just because it's more powerful, the telescope. It's also looking at a completely different wavelength. Like it's looking in the infrared, right? The Hubble Space Telescope, that's optical. It's what the stars are. It's what our eyes see.
Yeah.
So when you see it in the infrared, you see something completely different, something that your eyes will never see, right?
Yeah.
Because we don't have infrared in our eyes.
Just snakes.
Yeah.
Right?
That's it.
They see an infrared?
Yeah. Yeah, snakes,
Yeah?
insects.
Yeah.
Lots of reptiles do.
So
yeah.
they'd be look. I know this is dumb. I just say dumb shit sometimes.
But
if you're like a snake or an insect, you're looking at a full different universe to us.
Yeah, you would actually see the pillars of creation, or maybe not the pillars of creation, but you'd see nebula, these things that are like stellar nurseries where stars are being born. There's one right behind you.
Yeah. Pointed out.
Insects would see it.
Yeah, there it is. Well, I actually did see like with that aspect, and I don't know if this is the same sort of thing they're talking about, but it was Andromeda. The size of it, you could see it if it wasn't as dull.
Yeah.
And it
yeah,
was
right.
where you see it as a star, but the size it would be in the sky, and they put up a scale and went, oh well, fuck,
Yeah.
that's
So
that's
we
pretty
see it as
incredible.
a star, but it's actually a galaxy.
That's right. It's a galaxy. Yeah, actually, in
Wow.
the southern hemisphere, we don't actually really see it much. It really only just tips the horizon for us.
Yeah.
Northern hemisphere people get to see it, most of the time of the year. But it looks like if you know, just like out in the middle of nowhere, you'd see it like a blurry sort of disky shape. It wouldn't look pretty, at all. It would look pretty crummy.
Yeah.
Here in the southern hemisphere, like there's a few days a year that we actually just get a glimpse of it, and it's pretty crap to see.
Well, that's still incredible that
It is, yeah.
that it's still that scope in the sky.
Yeah, that's an entire other galaxy, just hanging out there. It's our nearest galaxy, and just like the scales that you think of.
That's what
when
fucks
comparing.
with my head, man.
Yeah.
The
The
scales
enormity
of
of the
these
size.
things.
Oh, man.
Or
Yeah.
just when they take a photo and then one section of that photo is billions of stars.
That's
The
it.
galaxies.
You're underestimating. Billions is too small a number.
Really?
Yeah, that's it. I mean,
Infinite.
almost infinite, I would say.
That's insane.
I mean, we get numb to it. Like astrophysicists, we deal with these billions, trillions,
Yeah,
gazillions.
yeah.
We'd run out of the words to use to describe these big numbers, right? We get numb to it. But the big number that I always think is the most baffling is this idea of how many stars are there.
Yeah.
And how many planets are around those stars. Like you look at our solar system with one star, and it's got 8 planets around it, maybe 9 if you still think Pluto's a planet, whatever.
I'll throw in some academic shade.
That's it. And then that's just one star of this galaxy, our Milky Way galaxy. That's 300 billion stars, right?
Yeah.
That's just one galaxy, the Milky Way. And then we know of trillions of galaxies that have these 300 billion stars, that have these 8 planets, around them, or whatever number of planets. And so the numbers just get insane, right?
So there has to be life.
And that's the other thing, right? And that's where this conclusion comes, right? A lot of people ask me, do you think life's out there? Well, I mean, I have one data point for life, and it's on this planet, right?
Yeah.
And we don't tend to extrapolate from one data point.
Yeah.
But I mean, you just do the numbers, and there's just simply no way that we have to be alone here, right? There's just no way, right? So that's why we're so keen to find that second data point, even if it's on another planet, if it's on a moon around a planet. That second data point all of a sudden opens up this question of like, okay, well, look, we found 2 data points.
Just a piece of bacteria, anything would
that's as simple as it has to be, right? Because from bacteria forms the next step, forms monkeys standing behind some mics talking about this.
Yes.
Joe Rogan.
Joe Rogan.
Yeah. So before we move on to the infinity of the universe, we'll go back to that telescope because you guys played a role in that.
Yeah, a lot of people don't realize this. WA, well, at least the International Centre for Radio Astronomy Research is where I work. We have a big part to play in the sort of processing of the data that comes down. Wow. If you saw the images when they came straight off the telescope, you'd be like, this is disgusting. What is this? This is like a VHS film, right? It's like terrible, crummy data. And so a lot of what we do is take that crap data and just process it, flatten it out. The optics of these telescopes are not actually that great.
Yeah.
We've got to sort of go in there. We're not photoshopping, but we're calibrating. We're
Fake
making
news.
it science. Yeah, that's
So
it.
this isn't. It's not a picture, is it? It's literally translating data of what you're reading.
This
coming
is
through.
fucking incredible. I didn't know this. So every picture we see, you create that from data?
Yeah, so exactly. We're collecting photons, right? We're just collecting photons in different positions.
Fuck?
It's like a camera in some ways, but you have to think about it slightly differently because this is an infrared camera, right? So it's not what our eyes see. You have to play this game of, all right, I've got, red, green, blue, but in the infrared. How do I translate that into something our human eyes actually can see?
How do they do it?
Yeah, we have to make some decisions, right? There's some artistic process. I'm not going to say it's like false color. It's definitely not false color. We make like clever decisions about what should be red, what should be green, what should be blue. But then it's sort of a matter of combining those images together to get that sort of, what your eyes would see, the cones in your eyes that detect red, green, blue. you just transition that into the infrared.
The physical structure of that is obviously the same. It's just the colours that...
Yeah, it's the colours. And you don't have to limit yourself to 3 colours anymore. RGB, you can say magenta, cyan, green, blue, and then you combine those together, and that's where you get these beautiful images that you're seeing, right? They're combining multiple colours together. And because you have that liberty to do that, you're not restricted to what the eye can do. You can choose what, accentuates the physical processes in that galaxy that you want to bring out, right? You could... enhance the dust that's in this galaxy. You can enhance the stars or the black holes. You can enhance different aspects of that image based on what colors you choose. And so there's some artistic process, but also it's a science decision at the end of the day.
So you're a bit of Leonardo da Vinci.
Yeah, I'd like to think so.
But having seen
Science
that as
and
well,
art.
the close up of the Eagle Nebula, the Pillars of Creation, and then they zoom out. And we see what the observable universe is,
insane.
and that one point, and I think I might have shared you, or you might have shared it to me, the video of it's expanding, going further back, and it just makes you feel so insignificant,
really
so
does.
small, but not inspired, but there's something to it.
There's something awe-inspiring about it for sure. Yeah, absolutely. Yeah.
Now, I'm going to go back to the Hubble.
Yeah.
So Hubble is what we can see with our optics.
Yeah, pretty much with our own eyes.
Was there any artistic creation with that one?
No, I mean, there's always this process of taking data and turning it into images. That's always the case, right? But no, I mean, at the end of the day, these things have lots of artifacts in them.
Yeah.
Lots of physical things in the universe that are acting to make it look crap, right? There's these things called cosmic rays that shoot across your images. We have to get rid of those, and there's lots of clever ways to go about that. But there's all these things that are out in space that you wouldn't otherwise have to deal with. Like, taking an image on the Earth, right? So we have to deal with those things after the fact.
Fuck, man. Okay. And
So
James...
Oh, sorry, go.
James Webb, who is he?
Yeah, I don't actually know that much about him. I don't think many people do know much about him. He's the second administrator of NASA, and sort of around the time that the Apollo missions were at their peak. So he's kind of
all the fake ones.
Yeah, well, that's it. Yeah, I'm not allowed to say that.
Yeah,
it's above my pay grade. Actually. Yeah.
So it's just named after him. It has nothing to do with the creator.
That's right. Edward Hubble was actually a really famous astrophysicist. Pretty much set the bedrock for modern astrophysics as far as we're concerned. So I don't know. I think they took a bit of a change in name scheme. They just decided to honor some.
And how does it? How does it actually work though? It sends out infrared light or it bounces back?
Reverse. Right? So it's collecting. It's like a big bucket, right? It's collecting light. Yeah. Right? Our eyes do exactly the same thing. It's actually, you want to think about it like it is an eye, which is way bigger, right? And the bigger your bucket is, the more photons, the more light you can collect, and the better your images are going to be.
And so this is what really bends my mind, is the fact that some of these images that we're seeing are millions or billions of years old.
Yeah.
So that galaxy may not exist anymore.
That's it.
And that planet may not exist anymore because this is...
how long the light's taken to get to us.
Yeah, exactly. Yeah. This is sort of game we play in astronomy. It's really helpful for us. It's like we're doing history in some way, right? Because light has a finite speed. It doesn't go infinitely fast. It's 3.8 times 10 to the million kilometers, right? So it's really, really fast.
That's how long I last in bed.
Jesus Christ. Getting it started. Yeah. So that light has taken time to get to us. There's a delay time involved. And for the sun, it's 8 light minutes, right? So it takes light 8 minutes to get from the sun to us. So if the sun exploded right now, we wouldn't know. 8 minutes, right?
The impact would probably get here quicker than we'd see.
Yeah, well, exactly.
Yeah.
Right, and so this happens for everything, right? So you go to the next, star rover, that's 4 light years away, right? 4 years.
Yeah.
And then...
So we're looking 4 years into the past.
Yeah, exactly. So if you send them a text message,
fucking mind-bending.
So which one is...
So that's Alpha Centauri. It's our closest stellar system. It's not a single star. It's actually 3 stars, 2 orbiting around each other, and then a third one going around those.
Binary star system, is that called? Or?
Yeah, it's a binary,
Jeez,
and this is actually a trinary.
They've even got gender identity out there.
It's a very progressive galaxy.
So
that's a binary star system with another star.
With a third star going around that binary. So this is actually a kind of baffling thing that if you look out in the night sky and you see all these dots, right? They're all stars except for a few planets.
Yeah.
The vast majority of those stars are probably binaries, trinaries, quaternions, etc.
With other stars.
Yeah, exactly.
That we can't see.
Yeah, well, they're so far away and they're so close to each other that they just look like a single star to our stupid monkey eyes, right?
Yeah.
So, our star being a single star in this solar system is actually pretty, I would say rare. It's the least common thing. So, it's kind of a question of, is that a special thing to have a single star? Does that favor life? Exactly right. If you have 2 stars sort of going around each other, you have day-night cycles that are fluctuating, and you have less rapid changes in temperature and all these kind of things that are going against the possibility of life. So when we go about looking for life, and it's not me specifically, but there are people that are in this field, right? They're looking for conditions around planets, around stars that are favorable towards, life
like
existing.
you said, we only have one data point, so we're trying to find something almost exactly the same as ours. So and a single star system with a planet that's within the Goldilocks zone.
Bingo. So it's a bit limiting in some ways because we think we know what life is.
Yeah,
right? It's a carbon-based water, drinking, breathing, oxygen kind of ecosystem, but we don't know what could be silicon-based or completely different atmospheric conditions are favorable.
We could be looking at something that's life and not know.
That's right. Yeah.
Because it's not what we recognise. Yeah. Just like the infrared's always been there that we can't see.
Is it potentially possible that we are in a binary system and we don't know?
No, we're definitely in a single system, but there's a potential that we were once in a binary system and our kind of brother or sister star is now kind of ventured off.
How do they determine that? Just because we've got the sun?
Yeah, I mean, the fact is that when stars form, they form together. Yeah. They don't just form in isolation. They form in these gas clouds. There's one behind you. It's a nebula. Yeah. This is where stars get formed, right? And they don't form in isolation. So we know that there are brothers and sisters to our own star. Mm-hmm. And often those things will be kind of orbiting around one another, kind of gravitationally bound. And then over time, they get sort of stripped and spread throughout the universe. So, well, the Milky Way.
So we potentially may have had one and then it's to a point where it's been stripped by.
That's right. And we're actually going out looking for these kind of brothers and sisters stars because there's these signatures that stars give off. There's particular elements that they're stronger in and other ones. So we're trying to look for those signature of our star or something that's very similar to our star to kind of indicate, this is one of our brother or sister stars, a star that we formed with.
Right.
Wowzers.
Like a fingerprint almost.
Exactly right. It's exactly that.
And our star, relatively compared to other stars, is pretty small.
Yeah, it's actually a pretty mediocre run-of-the-mill star. It's kind of a white, not too hot, not too cold, pretty small.
Shitty life-producing star.
Also, what are the other stars that we have?
I mean, it goes crazy, so you can go all the way down to these things called brown dwarfs or what are kind of failed stars. It's
not very PC in the science world, are we?
Well, we've got black holes.
Black holes, brown dwarfs, white sluts.
We call it as it is, It's like, it's black, it's a hole, yeah, sure.
Black hole.
Easy. And that's it, brown dwarfs. They're sort of brown in colour and they're small, they're dwarfs.
And don't emit much light.
So that's the thing, they're not big enough that fusion's not starting inside their core, right? So you need to get lots of pressure, lots of gravity going on. You got to get these atoms really close to one another to get fusion going. That's where you get the heat.
Yep.
They haven't got there yet, right? And they're not massive enough, and they probably won't. So we're thinking Jupiter is not far off being a brown dwarf. It's about 10 to 100 times less massive than a brown dwarf would be. So if it had been a little bit more massive, it would be a second star in our solar system.
And would that have any effect on us?
Absolutely. I think we wouldn't be around for sure.
Okay.
Yeah, no.
And as it is, though, it's probably one of the reasons that we are here. Served as almost like a shield.
Yeah, exactly. Jupiter's so massive that it really deflects all asteroids kind of coming towards us, and that's why we have this asteroid belt. It's this region where Jupiter's kind of collapsing and collecting all these different asteroids and rocks that would otherwise probably hurl into us.
So the fact that you bring that up, just while it triggers my memory, I don't know if this is a thing. Maybe it's a theory or maybe it's just fact. I don't know. The asteroid belt, is it just an existing ancient planet that was impacted and destroyed?
Yeah, that's right. We don't actually know. I mean, for the most part, there's lots of different hypotheses as to where the asteroid belt came from, but it's, most likely there was either a very large planet that kind of collided into another planet early on, and the debris from that is now spread along into an asteroid belt. But we don't really think that could be possible because over time, those different bits of debris also would form into another planet, right? Gravity would take over again, and that
is that accretion?
Yeah, that's accretion of mass, and that means that either this collision has happened very recently in our solar system for all this debris to be just in one kind of ring, or it's just Jupiter's gravity is just favouring a certain set of orbits for these things that they don't want to collide into one another.
And we don't know.
We don't know. No.
It's just
or maybe I don't know and I'm just talking shit.
And is that that's what you've just suggested there is similar to, is that how the moon was formed? Like a collision with our Earth?
Yeah, that's the big kind of prevailing theory for the moon, is that a massive sort of similar sized rock to our own Earth kind of came on a grazing angle, so it's not a direct collision but sort of swept onto the side of the thing and swept up heaps and heaps of material into the sort of atmosphere around Earth, and that material over time, gravity happens, right? Pulls it all together, and then you form the moon, because the moon itself is like massive compared to our Earth. You look at all the other moons around all the other planets, and they're all tiny in comparison, but our moon is about a quarter of the size of the Earth, which is comparatively really, really massive, right? Yeah. So that's kind of one of the theories, and the kind of other key piece of evidence for that is that the moon is tidally locked to the Earth, meaning we only ever see one side of the Earth at any given time.
Explain that, because I have no idea why that is.
Because its rotation takes the same amount of time.
Bingo. Yeah. Its day, so the time it takes to spin on its axis, is exactly the same as its year, the time it takes to go around the planet. Exactly.
Shit, like how though? That's
what?
There's some sort of I don't know about God, but there has to be some greater creation going on there.
It feels
divine
insane.
Intervention.
Yeah. It does. That one's not divine intervention, but I'll talk about one that I think
it doesn't slightly. There's not like a half a minute.
It's to the minute.
That's
right?
insane.
And the reason is because you have this preference to be in these stable orbits, right? It's like a resonance, a preference for that to be the case. You can kind of picture if you had like a perfect sphere with a little pimple on the side, right? That extra bit of mass on one side is getting tugged at by the Earth when it's going too fast, right? It's going way too far away, you're pulling it back. Yep. And if it's lagging behind, you pull it towards you, right? So no matter which way that pimple's on, it's always going towards the Earth, facing towards the Earth. So obviously the side that's facing us is the more massive side. Over time, it's just been tugged and tugged and tugged until it falls into that stable orbit. And once it's there, even slight perturbations are not going to move it out because it's in that stable orbit, right?
And the Chinese have a base on the back of it.
Well, they're putting one on the front, maybe to connect to the one on the back. Yeah, that's right. Yeah, we haven't seen the back for until like the 1950s. That's the first images that got sent back.
With the first Apollo mission?
No, even before that.
What was it called?
I don't know.
I did this with my year 12s.
I don't speak Russian, so it's probably
Sputnik?
Yeah, it was one of the early Russian ones.
Yeah.
Didn't they first designed it as a missile or something? There was like it was some missile.
Well, that's what the Apollo missions were. They got the Nazi missile designers and they used them for the
most rocket engineering advances come from army or military. Crazy.
From Hitler probably.
Yeah. But that makes me. I've now decided the moon isn't real. Yeah. It's artificially made. There's no way in my head it can go all the way around perfectly and eclipses be like their perfect distance.
That's not even the end of it, right? This is the bit that even baffles me, all right? So the sun, massive, right?
Yeah.
Huge thing. Colossal. I can't even describe how big it is, right? Yes. But it's also really far away. Right, so it also looks small. Yeah. But it happens that the sun...
people.
it just looks small because we're far away.
That's right. Yeah.
You're standing right in front of them.
yeah. Like it's an optical. Well, wait till you see it in infrared.
That's it. With a big telescope. Then you'll see.
Yeah. So sorry, I cut you off there. Yeah.
That's all right. So it's 400 times further away from the Earth than the sun is. But it's also 400 times larger, right? Those two numbers cancel out because how big something looks in the sky is a direct function of how far it is and how big it is. So that coincidence that it just happens to be 400 times further and 400 times more massive, the sun and the moon are exactly the same size in the sky. I mean, exactly, but they're pretty much exactly the same size in the sky.
So the chances for this to happen would be
insane. Yeah.
Insane.
And do you know what that means, right? And this is something that only humans, I think, could experience is solar eclipses, right? Where you have the sun get blocked out directly by the moon, right? And if the moon was any further away, it wouldn't block it out completely. If it was any closer, it would completely block it out. But they're exactly overlapping, and you get these really cool things, solar eclipses, lunar eclipses.
It illuminates the outside.
That's it.
It's insane.
It's incredible. And that's not just, in space. That's a spatial argument. But this is also temporal as well. This is in time because the moon is moving away from us, right? At some rates, like 5 centimeters a year. It's not very quick, but, that means in this current epoch that we're living in, that's the coincidence. So you come back 10,000 years or whatever, that's not going to be true anymore. Right, so this is a coincidence in space and it's a coincidence in time. It's something that I can't wrap my head around why this is the case.
Maybe it's not a coincidence.
Maybe not, maybe.
Maybe there is a God.
There we go. I've decided. Not even God. That is
too good for God.
That's the outsiders. That's them.
The lizard people.
We're looking for the life. There it is.
And they're probably responsible for making Mercury go in Gatorade, I'm sure.
Actually, I heard you say. I heard you explain Mercury in retrograde.
Yeah, in retrograde.
When in my very 2 little tweets that I looked at of yours in research of this, and you were explaining Mercury in retrograde. Can you explain that for the listeners?
I find this really fascinating.
Pretty interesting.
less the physics of it and why it's the case, more the like sort of hype that goes around. Really fascinating. Yeah. So in a similar way, right, we've got this tidally locked system of the moon and the Earth. Yeah, Mercury is also tidally locked. It turns out this happens to any system where you have one massive thing and one small thing very close to each other. Right. The difference is with Mercury, it's not in a 1-to-1 ratio. It's in a 3-to-2 ratio. Almost exactly. Again, down to the second, down to the minute, whatever.
Yeah.
3-to-2 is the resonance that it happens to sit in, right?
Is this with Mercury and its moon?
Mercury and the sun.
And the sun,
So slightly different to the Earth moon, but it's the same kind of concept, right, with matter. So that means every 3 orbits it does around the sun, it spins twice. 3-to-2, exactly, down to the minute, right?
Wow.
What that means, at certain times of the years, it looks like from the Earth's perspective, that Mercury's spinning the other way around. And it's just because of this 3-to-2 ratio. It's sort of like, if you're in a running race and, someone's catching up to you, it looks like or you're kind of falling behind. It looks like they're going forward, but in fact, you're just going backwards, right? That's the concept here.
Yep.
And so there's this kind of craze that goes around this time of year where, like, when Mercury's appearing to go the other way around, things, you shouldn't go traveling and you shouldn't sort of make any business deals. But of course, it's still just rotating as it always was. It just looks to us.
And is that called retrograde when it looks
retrograde.
like?
Yeah, but that's actually false retrograde. That's and it looks like it's in retrograde.
And your point was that there are always good and bad things happening consistently.
That's
so
it.
when the bad things happen during this point, they make a point of it.
That's it. Exactly right. They're like, I notice it more during retrograde, right?
Yeah. Does retrograde, the actual word, because I've never even thought about what that means, does that just mean going in an opposite direction?
In the opposite direction, exactly. So if you look at all the planets in the solar system, all but one of them are going the same way as the sun is rotating, as the way they're going around the sun. The only one that isn't is Venus. It's actually going the opposite way. It's truly going in retrograde. Yeah, exactly. Venus, right?
So Venus is the hotter surface.
That's it. Yeah.
And Mercury, even though it's further away.
Yeah. That's kind of like a greenhouse effect taken over.
Yeah. Wow.
Mercury, actually, weirdly enough, I guess, what would happen on Mercury? You'd either burn to death or you'd freeze to death.
Yeah.
Actually, it depends on which side you're on.
Wow.
Right? So if you're on the side, remember this 3-to-2 ratio, that means for a long time you're actually facing the sun, right? And you're getting burnt to death. But on the other side, you're not really facing the sun for a long period of the year. So, it gets really cold on that side. You'd probably freeze to death on the other side of Mercury.
Would there be a Goldilocks zone?
Yeah. What if you're on the equator?
Right on the equator, but like the latitude equator.
Like 20 degrees and sunny.
Like
nice.
you just have to pack up every few weeks to move across. Yeah, exactly right.
Oh, fuck.
Yeah.
How do they figure out that a planet's spinning? Like, how do they know? How do you see? Is it because of light reflecting at a different speed, or?
Yeah, the easiest one is Jupiter, right? If you look at Jupiter, it's got a massive storm on it. This is a storm that's like many times the size of the Earth, right?
Yeah.
It's a giant storm.
And how do they know that's a storm, bro? Because that's what I'm thinking. Are we theorizing it?
They crashed a probe into it.
Yes,
that's how they know.
I remember watching this documentary.
Schumacher, one of the not the racer.
Yeah,
Schumacher Levy 8 or something.
That's the one, the very same. Yeah. So
mate, I'm fucking nailing this.
On the top of this.
So
this is memories.
Crashed a probe in there.
They've actually crashed many into it, right?
Just for fun?
Yeah, exactly. Because you don't know what's going to happen, right? We don't.
What if there's
life?
People down there like, stop fucking doing this.
Just have a peaceful, summer's evening.
So they've built a probe, crashed it in there.
Yeah.
And
billions of dollars go into these probes and they crash them into planets, right? Yeah. Record pictures as it gets closer and closer and closer until it gets, completely destroyed by the crazy winds that are on Jupiter. Yeah. This happens quite often, but the real reason is not just a waste of money, right? The real reason is that if you don't crash them into the planet, that probe could go elsewhere into space, right? And that probe has bacteria on it coming from Earth, right? If it crashes into a moon and then, I don't know, whatever, 100 years later you go to that moon, you're like, oh, look, I found some bacteria. Well, actually, that's probably come from
Mars.
Could have,
but don't we have that issue already with the probe that we lost contact with? What's
Voyager. This one's kind of Voyager 2, actually. It's gone beyond the solar system, we think.
Would that be the issue you'd face with that?
Yeah, look, that's not going onto a planet, and I don't think we'll ever hear from that ever again. So I think that's the one, we can keep that one. Rest the case on that one.
Yeah.
I remember, actually, when you were talking about Jupiter, one of my students wrote, because I used to teach science, students wrote, Jupiter's mass is, and they wrote out this huge number, and in brackets they put, but not as heavy as your mum.
Damn.
On the poster.
Kids are brutal.
I was like, that's funny. I got one mark.
Yeah,
so
double marks.
I didn't realise this. So when as a kid, Jupiter is a gaseous planet, they call it.
Bingo.
And I just thought that, that's literally just gas.
That's not far off the truth, yeah.
Okay, so why, and in a similar vein, they've crashed a probe into it. The asteroid that hit, and then we actually got footage of it for that first time. We see the plume come up out of the storm. Well, not the storm, but
it is a storm, yeah, definitely.
Yeah, out of that. So, at what point do you realize there's a surface, or what is it? Just the gas is so dense it becomes physical.
Yeah, we don't actually think there is a surface to Jupiter, any kind of definable surface. What happens is you've got this gas that's really diffuse, and then you go closer and closer to the surface, and it gets kind of thicker, and it's maybe it's kind of swishy, and then it goes further and further, and it's maybe sludgy, blah blah blah. Keep going down, 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 and then at some point you hit where we think fusion might be happening, right?
Yep.
These things at some point, if they were more massive, that gas would get so dense that it would start fusing with itself and forming radiation.
So in the sense, like of a way a star forms, it's the gravity pushes down. It's the same way as
it's all the same, just at a smaller scale. Physics is pretty.
And Saturn is similar.
Saturn's very similar, it's just a bit smaller, right? So, but it's also more gaseous. It has more gas than rock in it. So light, in fact, that if you got a pool big enough of water and you put Saturn in it, it would actually float because it's actually less dense than water is on average.
All right. Now you say that. How do we know?
Yeah, I mean, we don't. We have never done it, right?
No, but I mean, not that it'll float. Like, how do we know that Saturn is not dense?
Yeah, I mean, it's just a matter of, collecting samples of the atmosphere or just looking at the atmosphere that's there. We can do that using telescopes. You can look at what's in the atmosphere with certain telescopes.
How?
Okay, yeah, you've gone. This is actually a lot of what I do as research. It's something called spectroscopy, right? Spectroscopy. So spectroscopy just means, spectra, so you're splitting up light.
Yeah.
If you've ever seen the Pink Floyd album, you see white light going in and it splits into lots of colors.
Yeah.
Those colors aren't just, colors that our eyes see. Certain frequencies, certain specific colors correlate with certain chemicals, right?
Yes.
So hydrogen.
Like mass spectrometry?
Bingo, exactly. So that's exactly what you're doing, but it's chemical spectroscopy, right? So you're looking at the specific chemicals that are in that material.
Yeah.
And the way to do that is you have light passing through the planet's atmosphere, and there can be a background star, right? And you look for what's missing, right? Because that's where those particles have absorbed that specific frequency. And the more that it's absorbed, the more that's there, right? So you look at Saturn, lots of hydrogen, lots of helium, lots of that stuff.
Yeah,
In fact,
because it's absorbing that
It's absorbing
frequency.
those specific frequencies that we know here on Earth by looking in a lab, right? We've got a container of hydrogen, you put light through it, that goes missing, those specific frequencies. So you look at it, and you just do it with a planet, you can do the same. Now, this gets crazy, right? Because if you think about what we can do with that, we look at other planets around other stars, right? Like, Proxima Centauri, whatever. And you start looking at the atmospheres of the planets around those from the starlight that's going through their atmospheres, and then you can start seeing things like methane, right?
Yeah.
What produces methane?
Carbon and 4
life.
hydrogens.
Exactly. Bingo. But only in a biological sense can you produce certain chemicals, right? So we know that on Earth...
So methane's only produced by...
Actually, no, methane is naturally producing, but there are certain chemicals, I don't know the signatures off the top of my head, of course, but there are certain chemicals that could only be formed, we think, right, by biological life.
Yeah.
Life producing this as a waste product essentially through whatever.
Wow.
So you look for those chemicals, and if you find them, that's a pretty good indication that there's life there, right?
Through assessing the light.
Spectroscopy, it's huge. And James Webb Space Telescope is doing this already, right? And they pointed at a few planets nearby, and they found vapor water, so water in sort of the atmospheres of planets, right? That's also
Is that
really
a first?
I think we've found it before, but not to this degree, right? And not in something so far away, because it gets really hard the further away you look, the weaker these signals get. So you're really limited to the next closest stars over.
Yeah.
But not every star has planets, so you only get sort of lucky if you see something. But for the first time, we saw a really far star away, has a planet on it, didn't even know that planet was there.
Yeah.
Wow.
And now you're seeing,
Bit of water.
So water is like probably one of the best signs of life.
It is, yeah. I mean, you need, again, as far as we're concerned, humans or intelligent life needs some sort of water to produce. But there's methane systems in the world, in different planets and different moons that have that similar rain and sort of laking and pools and this sort of cycles that we see in water. You can see that in methane as well. The other chemicals will do that, but we only know of water to harbour life, right?
It is interesting because I did watch a documentary in which we have this idea of a Goldilocks zone, but then they were experimenting with our own planet, trying to find the most extreme environments on planet Earth and see if life can exist there, like in volcanoes and these sorts of things. And they were finding bacteria and even not even
extremophiles.
I guess that really it
opens up the scope.
It's good, but it makes that it's less defined and makes it harder. Would it a little?
I mean, it gives you more options. So can't complain with more options. But it means you have to get a little creative with what you think life could be, right? Yeah.
So I really can't. I'm struggling to get my head around. This whole time until today, I thought the telescope was we're looking out and we're just zooming in, but it's the opposite. We're collecting light,
magnifying it on a certain point, and then looking at it in detail after the fact. Right?
I think everyone has that sort of idea as well. I feel like even though I half knew what you were talking about, I still have this vision of like it's a photo.
That's right.
How does it collect light, man? We got like a bucket. We said this earlier on, but how is it drawing light into it, or it's not? It's just observing a point. Like, how is that part getting more light than the patch next door?
So they use curved mirrors.
Yeah.
Right? So if you have a mirror that's curved, it'll focus that light on a certain point.
Yep.
Right. And that's what you want to do. You want to take that light that's coming in sort of at a plane. And
Famously known for burning ants.
That's it.
Yep.
It's exactly that, right? It's a lens, right? You can actually use a piece of glass to do the same, right? It's a curved lens.
Yep.
Focuses that light on a certain point.
Right.
And then it magnifies. That's where it's the brightest point. And so you put your camera right at where that magnifying glass is at its hottest. That's where it's focusing in on the light. Yeah.
And if there's any dust, any scratch,
scratches are, we can deal with scratches. In fact, the James Webb Space Telescope's already been hit like 3 or 4 times by micrometeorites, right?
Yeah.
A few times.
Hang on. The James is not on Earth?
No, it's in space.
That's what he was saying.
Oh, what the fuck?
When we were saying like you have to deal with all the stuff that's on the planet Earth, so we launch it from the outside, so you're actually you're dealing with the atmosphere.
Yeah,
just
the worst thing about being on this planet is that, it's great to have an atmosphere, obviously, it means we can breathe, but for images, it just blurs everything, makes everything really crummy looking and downs the resolution completely. So you put them in space, and then all of a sudden, you have these.
And is Hubble in space?
Hubble's also in space. This is like
did you not?
No, man. I thought it was like on Earth, and we're just trying to.
Here's the crazy thing, though. Hubble Space Telescope, it's out of the Earth's orbit, but it's like just on the cusp of the Earth, right? I would call it kind of right in the Earth's atmosphere, right? Pretty much just on the very, very top part. James Webb is really, really far away, right?
Yeah.
Like millions of kilometers away.
So like moon further away, or
it's 4 times further than the moon, right?
Wow.
4 times further. And the moon's not even close. Like, I think people think, the moon, it's like, just there. But no, the moon is really freaking far away as well.
Almost like you couldn't get to it.
And
in 1964.
It orbits the Earth?
It's okay. This gets really weird. It orbits a place in space that is a stable gravitational point. It's called a Lagrange point.
What
right?
the fuck?
Yeah.
Go on.
Okay.
You've opened the can here, right? It's sort of like this resonance that we were talking about. It's this stable point, right? Where if you try to move out of it, you kind of dip back into it. If you move this way, you get dip back into
Toxic relationship.
It's like you try to move away and try to distance yourself, and it just keeps coming back.
Keeps coming back.
Exactly right. So that's it. And it orbits this place.
But it's just a void.
It's pretty much a void. And the great thing
but it has gravity. But don't you need mass to create gravity?
Yeah, the sun.
So the sun is creating this little Lagrange, is that what it's called?
Yeah,
Sounds like a wine.
Is it through its rays that it sort of sends out these points?
It's the combination. Well, this is where things get crazy, right? Everything you're saying is correct. You're actually, I think you're giving yourself a little too much hard time because everything you're saying is correct, right? This is what's happening. The sun is, it's gravitationally creating this field around it, right? The way we think about it, right? If you think of it like a rubber sheet on a table, you put a bit of mass there, it kind of distorts that space, right? And that's what the sun's doing. You put the Earth in there, and suddenly you have these 2 systems that are orbiting around each other, and there's points in that rubber, film that are more stable than other points. Some points will, send you directly into the sun.
Yes.
Some will keep you sort of in a stable point, and that's where we put the James Webb Space Telescope in.
How did they find that? Was it theorized or?
That's above my pay grade.
Yeah.
Look, we know about them from simulations, and we know about it from.
That's so insane.
And that leads into something that I don't know if you're going to be able to explain to us very well.
I might not know.
I'm loving this.
I'll make something
You're
up
doing
anyway.
this is great, Dr. Cook.
So like black holes.
Here we go.
So
yeah, mum.
They're invisible. They're I guess to a certain extent they are. Well,
by definition,
the singularity is clearly invisible, but they're invisible. They were theorized before they were even seen.
Yeah.
So that.
But we still haven't seen them, right?
No, now we have.
We've seen them
have?
now.
Well, it depends what you mean by seen, right?
Yeah.
Black holes are so massive, right, that not even light itself can escape, right? So by
gravity
definition,
is so strong,
infinitely strong almost, right? Because it's an infinite amount of mass in a tiny amount of space, right? This is getting crazy.
My body.
Infinite mass, little
space.
body.
Yeah.
Yeah. So not even light can escape. So yeah, by definition, it's invisible. We can't see past a certain point, right? So when we say we've seen them. No, we haven't seen them. We've seen their effects. Yeah, exactly. Their shadow.
So for people that don't know about black holes, they're theorized because they're having an effect on everything around it. Like, let's say there's a what would it be in the universe? Not a blank spot.
Yeah, pretty much. Yeah,
just a blank spot, and things are getting pulled towards it or bending around
bending
it.
Of light.
Bending of light. This is the key thing, right? And so this is where Einstein came in. He said, look, if you've got enough mass somewhere in the universe, its effect will be so strong that it will bend light, right? But we know light has no mass, and so Newton and all the eggheads at the time were like, well, that can't be the case because. So
that was the theory, though.
And that was the big theory, right? It's like how can mass, be bending light when light itself is massless, right? Gravity, we always think of an attraction between two masses, but light itself doesn't have mass, so how could it possibly be attracted? Now, this loops back to what we were talking about earlier, where the sun and the moon have this coincidence in them where they're the exact same size in the sky. That's a really convenient thing for us because all of a sudden you can look at stars that are sort of right on the edge of the sun when it's getting blocked out, and you can look at how much their light is being bent, right? This you wouldn't be able to do this because if you even looked at the sun like with a telescope, it would just destroy your optics completely, right? So the fact you can look at stars that are right on the edge of the sun during these solar eclipses, you can see how much that light is actually being bent. And they did this in 1918, right? They went up to
1918.
Yeah, 100 years ago actually,
almost. Fuck?
And they proved Einstein correct with this simple observation, right? They were just like, look at these stars. They were here, now they're over here. They've been bent by the exact amount, like down to the arc second that Einstein had predicted. And then it kind of proved general relativity correct. So, Einstein was right once again.
When was Einstein born? 1800s?
1890s?
Right.
1880s? Don't quote me on that.
Wow.
Yeah, right. And so...
I guess they didn't have Xboxes, so...
They're
looking at that shit.
So many distractions in the world, I guess there are a lot.
Yeah.
But, so the whole... and I'll say what I feel like.
This is
my
Branch's crowning doctorate moment. He's doing his master's thesis.
My brief, dumb understanding of what a black hole is, and then you can go into it. So
I thought you were going to do your theory.
No, I'll do my theory
awesome.
a moment because that'll expand.
Imagine if he goes, that is correct.
Yes,
you are doctor.
With a sword, knight you.
So black holes, as far as I understand, are one of two things. They're either they're a collapsed star that's reached the end of its life, where the gravity has become so much and it creates a black hole, and a supermassive black hole, which is at the center of every one thing. I was like, it's the center of every galaxy, but also I'm just like, couldn't they come up with a more complicated name?
That's in astronomy.
Supermassive. It's black.
It's not just massive. It's not just black. It's supermassive.
It sounds like Donald Trump named it.
Yeah.
Supermassive.
Supermassive. But yeah, so supermassive black holes. They're at well, actually, we'll go into them next. First, explain the black holes that are created by stars.
Yeah, that's right. So, at some point, a star dies, right? Our own star's going to die in about 4 billion years. So if we're still around, that'll be pretty cool.
Yeah, I reckon we'll be done by next year with Russia.
A few nukes here and there, right? Yep. Yeah. So at some point, stars run out of fuel, right? And the fuel is what's kind of creating that fusion. That fusion,
expensive.
Yeah, I mean, with the tariffs and whatnot going on, it's expensive running stars out here. That's it. Right, so at some point they just give up. They basically give up. That energy just stops giving out radiation, stops creating that pressure, and then it collapses in on itself, right? And that collapse creates a rebound effect. And this is this supernova, stars explode, and at some point they'll sort of either do one of two things. If they're really massive, if they're not massive, like our own sun, they'll just form a white dwarf, this sort of dormant, kind of not light-giving sort of object in space. Or if they're really massive, that mass will kind of stay around for a while, keep collapsing in on itself with nothing to push it outwards, right? No more energy. And it'll form an infinitely massive, infinitely dense, I should say, point where all that mass is in a single point in space. Singularity.
How do they know? How do they know?
Well, we're going to have to trust Einstein on this one.
So that's a theorized.
That's mathematically what we believe would be the case.
It doesn't make sense.
We don't know 100% what the go is with black holes.
Exactly right. We've tried to create black holes on Earth. That sounds kind of crazy.
Yes.
Who would want to do that?
In the
what if it collapses in on itself?
Exactly, in the Hadron Collider. You smash things together so much so that they, the particles are overlapping themselves in space, which is a crazy idea to think about, that two things can be overlapping in space.
How? Yeah.
Exactly.
Because it's not three-dimensional then.
Well, this is
Is
where
it a different dimension?
this is where quantum comes in, right? So quantum, it deals with everything that's at the small level.
Yeah.
Hey, don't spoil Ant-Man for me.
Yeah, it's not good. No. So look, at some point, matter just stops making sense, right? You don't just have physical balls that define atoms; they're just empty space for the most part, right?
Yeah.
And so you can kind of think about, well, if I'm just putting empty space over empty space, then that's possible, right? But if you have this sort of archaic view that atoms are these physical objects, like two balls, of course you can't put them on top of each other, but they're not that. They're kind of clouds of space. They're not really physical objects.
Yeah,
Right. So that's this idea, and that's what's happening in a black hole. You're getting all of that material, you're overlapping it on itself, right? It gets infinitely dense.
And it's the gravity that is bringing it in.
Yeah, and it's a vicious cycle, right? Because then as soon as you get more massive, you're pulling in more stuff, and if you're pulling in more stuff, you get more massive, blah blah blah, and you end up with this sort of runaway effect of a black hole.
This hurts my head.
And then at what point so it reaches a tipping point for a black hole as well, because that can die and end. Is that right?
There's
Where does it go?
Yeah, that's what I want to know.
There's something called Hawking radiation, which is
yeah.
like evaporation of black holes, but that takes many, many times the age of the universe to evaporate a black hole. So that's probably not what happens.
Okay.
We think they just hang around. They're just chilling out in space.
And are they like a tiny dot?
I can't tell you.
Yeah.
And so because
Is that the theory though, that it gets so pulled in on itself, it's just this little spot?
I don't even want to call it a dot, because a dot implies that there's some physical space to it, right? Even a dot takes space on a piece of paper, right? It's smaller than that. It's infinitely small.
What if you're just in a spaceship and you hit it?
Oh, okay. Now this is great. This is great. All right. Time travel, right?
Yeah.
Okay.
You can actually do time travel, but only one way. You can go forwards in time. And the way you do it, this is crazy, all right? This is going to blow your minds. So if you go close to a black hole, the gravity there is so strong that your time is moving more slowly than the time of someone that's not at the black hole. This is called
Interstellar?
This is Interstellar. Did they do a good way of
Interstellar is
explaining?
one of the best movies I've seen that kind of actually takes true to the science itself. Yeah, absolutely. This is what's happening, right? As you're getting close to that black hole, time is slowing down. It's called time dilation. For you, right? It's not like your clock is functioning slow and you're not like going in slow-mo. You're living your life as you would, but just time is relative, right? It doesn't actually have there's not a fixed clock in the universe, right?
Yeah.
And then you come back, having journeyed to your black hole, and you come back and people have been, living their lives many times quicker than you have, and so all of a sudden you've kind of traveled forwards in time.
What the fuck?
Yeah,
Hang
this
on.
is legit, and it's definitely possible.
So
at what point does because we're talking before you get to the event horizon part of a black hole. This is just within the boundaries of the gravity pulling you towards
The
it.
closer you get, the more time dilates. So
why? I don't get this. Hang on.
There's a
So
small
the way
vein.
I experience time is
linear.
different
It's linear, yeah.
to how you're experiencing time.
Yeah, that's right. Exactly.
Oh,
How
that
crazy
doesn't
is
make
that?
any sense.
There's this little vein forming at the end of Daniel's head where it's
Yeah.
just like his brain's gonna like melt.
Yeah.
if I tell him one more thing.
But that's
How
like
come-
a three-dimensional way of thinking about it, isn't it? So you have to go past a third-dimensional way of
Yeah,
thinking and
exactly.
thinking of bending space and time. And I've seen how like we're at that point where time travel and moving to distant planets and galaxies is not going there in a straight direction in a rocket is not how we will do it.
Not
It will
optimal.
be bending space
it.
and time to make that point and that point the same point.
Nothing's
Yeah.
free
So
in the universe.
You're doing Scorpion. Get over here. And you're just pulling them closer
We
together.
don't have a piece of paper, but you've seen that.
Yeah,
Everyone's
when it
seen
folds.
that. Yeah, and put the pencil.
Is that legit, or is that just something they do for the
Or is it-
movies?
That's where we get into the theory.
Yeah.
Right? That's a possible mathematical explanation for what you could do and we do think this is correct. General relativity is this explanation of bending space.
Yeah.
If it's true, and we definitely think it is because we can't disprove it at this point, we're trying to.
Yeah.
If that was true, then mathematically you can have these situations where you can puncture space and travel shorter distances than the physical space between them by kind of venting between them.
Because if you can bend light, you can bend space.
Yeah, well, actually, what you're doing is bending space, and light's actually traveling.
So you're
a
already
straight
bending
line.
space.
You're
and
already
the
bending
light-
space. Light's actually traveling, for all it's concerned, in a straight line, but it doesn't realize that it's in space, which is bent, right? It's traveling in a straight line.
That
Yeah.
makes
And the straightest line in bent space is a curve to those observing it, right? That's the mind-bending bit.
wow. We discovered fire. Yeah. So okay. We
I want to go back to this experiencing time
Okay, yep. We'll go back to that experiencing time because then I want to. Go to that while we're on it.
So, why, if I'm experiencing time here, right, like an hour, why? And I know clocks go a bit slower the further they are away from the Earth, right?
That's right. Yeah.
But why? Like, why does time change for me?
Yeah.
Because time's not a thing.
Exactly. Every word you used there was a human word.
Yeah.
Hour, clock,
Yeah.
time. These are all human constructs. You can't really use those words in the context of general relativity, of bending space, because they're just so outside of our concept of what it means to be time, right?
Yeah.
The only thing I can say to this is that nothing in the universe is free. You can't just create stuff without some cost.
Yeah.
If you're going to go to the trouble of bending space, right, you've got to pay some way. And the way to pay for it is to bend time, slow time down, right? So there's this correlation that happens between space and time, right? Space is not this independent thing. There is a 4-dimensional world that we live in, space and time, 3 dimensions and 1 in time.
Yeah.
Those two things aren't disconnected. They are related. And so if you stretch length, you collapse time, right? And vice versa. Nothing's for free.
Okay.
Nothing's for
So
free.
it's more. It's like that idea of or the
Conserving.
theory of the every action has an equal and opposite reaction.
Yeah, it's conservation of matter in some ways, right? Newton, way back to the good old days of Newton, where
So
things just fell
spread
from
it out that
apple
way.
trees.
Yeah, collapses in that way.
Nothing's for free. There's a
Okay.
cost, and that's what it is. Time.
Okay,
Wow.
that makes more because I was
Somebody
I was
has-
struggling to like process it in my head, but that sort of visualization of it makes me
Even for me, I don't even conceptualize it myself, right?
Yeah.
I still don't have that grasp of what this actually means and what it, for a human to experience that.
And Einstein was doing this shit without Google.
That's it.
Like, he was creating that, man. That is insane.
and-
Something has to be bigger than just. What's your theory on God then? Now that you're an astrophysicist.
Yeah. Look.
Well, and take away from the dogmatic religion of God.
Yeah.
Go down the idea of God, a creator, like a
source
infinite source energy.
Yeah, look, I think there's this idea that I kind of come to grips with is God of the gaps, right? Which is like, I don't have an explanation for this thing, therefore God must have done it, right? This is called God of the gaps. We didn't have an explanation for, stars out in the sky, so therefore God must have put them out there, right? And so every time God gets explained, used to explain a certain phenomenon, science has proven it wrong, right? So it's hard for me to kind of come to the grips with just filling blanks with God did it or some divine being did
That
it.
400, man.
Yeah.
Well, the 3-2.
Yeah.
And the distance.
Yeah.
And the 28 days.
It's all, and that's the thing. Like,
So this is where we'll go down my theory on that point.
This is really good.
So the Big Bang.
Yeah.
Okay. Well, actually, that comes to it.
Wasn't big, wasn't a bang. Just to be clear.
Okay. So, this may be. This is just and not a theory. This is just me using my logic of.
We're going to need
to
do another podcast.
Yeah, I think so because I've got so many more questions. But so if we know that a black hole is just the sun collapsing in on itself to a point in which it expands. It collapses so much that it ends up sort of sucking everything into it. Keeps going, and we see that with supermassive black holes. Basically, the galaxies are just everything that's within the realms of that.
Into it,
yeah, exactly. So as we know, the universe, as old mate said, the universe is expanding, and we know it's going out. And it's
Who said that? That was I don't know. What impression was that?
And we know it's no, I don't know if we know. You can it's theorized that it's going to then collapse in on itself, the universe.
Because we're rebounding, like you said before, or it's
so if the
rebounding
universe is just a larger version of what a black hole is that potentially what the Big Bang was? Just the universe collapsing in on itself, bang, and starting again.
Yeah, we don't actually know what's the fate of the universe, right? There's a few different ideas. You either keep expanding infinitely, right, to the point where the distance between everything is so far that everything just cools down. It's called the big freeze, right? Again, astronomers.
Yeah.
Very good.
Freeze, right?
Yeah, so big, so freezing.
Amazing. And then the big crunch is the opposite, where at some point gravity takes over again, and that expansion gets kind of stifled, and things go backwards and collapse back in on themselves. And this is this idea that maybe, the Big Bang was just that rebound happening over and over again, right? Over these billion-year cycles.
That's another toxic relationship. Big bang on a
rebounding.
rebound.
So I wasn't wrong, as a theory. It's a potential theory.
Absolutely, yeah. And that's, I mean,
Doctor.
Yeah, Beyonce.
Cool.
So,
your contributions to science.
It just makes sense in my logical head.
But if that's to happen while we're on Earth, we're fucked, right?
Yeah.
Oh,
absolutely.
We just get smashed into fuck all.
You wouldn't even feel it. It'd be that instant.
That's, again, my sex life.
You wouldn't feel it.
So, what's your theory? What do you subscribe to? What do you tend to favour? Or what is the academic outlook? Or is it completely split down the middle?
Yeah, it's split for the most part. And that's the thing, because there's little evidence that you can kind of point to what could be the potential extrapolation of the universe, right? Again, this is the idea of extrapolating, right? We tend not to do it because it can go many different ways, right? Yep. It doesn't converge. So, I don't know. I like the idea that we're on this kind of cycle, because that checks out as far as like my human brain understands that cycles exist there, and then you don't have this problem of beginning and end. It's infinite. It's infinite, right? It's always been happening, and one of the big questions that people ask is what happened before the Big Bang. Well, we can't know because it's physically impossible to know, right? But it also just voids that question altogether, because if you have this sort of looping of the universe, then it all kind of comes together. And that's why I like it, but it doesn't mean that it's correct, right? It makes me feel more comfortable at night, but I feel
far more comfortable with it. I'm sticking with it.
Yeah, that's it.
When they say God knows.
But I guess that's what all good scientists would do, is they have a theory.
Yeah,
but
we try to prove it wrong.
Yeah.
Yeah, this is the difference about science compared to most kind of like fields or kind of jobs that you'd be out there. You're not trying to prove yourself correct for the most part. You're trying to prove yourself incorrect, right? Because if you just kept proving yourself correct, no one would learn anything. Confirmation bias, you wouldn't learn anything. It'd be boring. If you're proving yourself incorrect, that's where the exciting stuff comes out, right? This is why we're on this mission to prove Einstein incorrect. We haven't done it yet, but we're on this mission because as soon as we prove his theory is incorrect, that's where we discover something new, right? So it's hard actually for scientists that, like, especially young budding scientists, because you're coming
Einstein's
into this
already done it all.
Either it's all been done or anything that you put forward is going to get kind of hailed down, because it's all about proving things incorrect, right?
And there must be.
I wish they did that with the vaccine.
Yeah.
So there must.
Actually, some science.
There must be, I guess, a bit of like. You just mentioned the young scientists coming up trying to. There must be a bit of stay in your lane. Like,
yeah, what's it like out there as a professor? Because you're like a young guy, 27.
Probably as young as you can be to be an astrophysicist.
That's pretty awesome. Is that like pretty rare?
Oh no, I think actually these days young people are getting more into the sciences than ever before, right?
How did you always want to do this, or were you just good at physics at school?
Not even. No, I was a bit of an idiot. I liked physics. No, I had one really good teacher, good physics teacher, and he did astronomy, and he got me passionate about astronomy. And then I just realized,
one teacher.
What
was his name? Give him a shout out.
Yeah, Paul Zamponia. He knows me. I know him well. I go teach his students as well. So occasionally,
sick.
Great guy.
What school?
Duncraig Senior High School.
Really?
Yeah, just up
shout
north.
out.
Yeah, that's
in the
it.
area.
Yeah, just up north. Yeah, that's right. Yeah,
cool.
Represent.
Yeah. So you got a little spur from that.
Yeah, I got a spur. I think I always like understanding how things work. Right, that's just so exciting when you figure out that that's how a microwave works, or that's how this happens.
Or when you get round to women, let me know.
Yeah. No, well, there's some questions in the universe just need to stay unanswered, right? Steer clear of that one, right? Mm-hmm. I'd rather talk about black holes. But yeah, like I think that's just an exciting thing to do. And then so you look at astronomy, it's like we know shit all. Like, where as far as the universe is concerned, we know this tiny little slither of what we think we know, right? And then there's everything else out there. And there's this idea that like every time you discover something, you discover two other things that you don't know, right? Yeah. So it's like this journey of continuously, learning new things, but then learning how much you also don't know.
Because what is it? You don't know what you don't know.
You don't know. There's the three knows, right? It's like the things you know, right? The planets, the stars, all the matter. There's the things you don't know, and that's like black holes. We don't know about black holes. We don't know about dark energy, this sort of expansion of the universe. Yep. And then there's the things we don't even know that we don't know yet, right? And I can't even list those because I don't know them.
I heard Neil deGrasse Tyson talking about this the other day.
Well, he ripped it from Carl Sagan. So,
okay,
and I'm ripping it from Neil. So,
but this whole idea of like, we don't know.
Because you learn something new and then you don't know something about that new something.
Yeah, so and he used it to reference, climate change and a few things that like we were worrying about something else in 1900, completely different. We didn't know about the other things. But that idea of we don't know what we don't know is scary.
Yeah. And sometimes you got to stick to your guns a little bit. You've got to be like, this is what I think I know. But, you know that you're probably going to be disproven in 10 years. Some smart person's going to come along and go, well, actually, what you thought you knew because you had this small subset of data that kind of explained your results is actually completely wrong because now look at all this other data we have. So yeah, in some ways you've got to understand that, you know, most of science is wrong from the get-go. It's something we come to grips with, is that most of the science we're putting out there is not correct by definition, but that's not a problem because we know that science is this journey of continuously proving yourself wrong, blah, 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 learning more along the way.
So we'd like, for example, we'd know it mathematically we probably can't survive going into a black hole.
Probably not.
But
we don't know.
But we don't know, do we? So is that a potential a warp point in time that we're talking about before? Like, are those things? And then I know you don't know, but is there potentials with those? And then coming up with those sorts of theories, is there sort of
what are you talking about?
Like black holes, like going into them. Yeah.
Well, this is what
I'm asking you.
Oh yeah.
So you're talking about going into a black hole?
Yes.
Okay. What was warping?
So if you die, it's pretty widely accepted that you're going to die if you go into a black hole. But we don't know that. But if we didn't,
what would happen?
And
this is where Interstellar, I think, is a good movie in some regards, because it gets crazy when McConaughey goes into the black hole and things go kind of crazy and n-dimensional. I think that's really clever because we don't actually know what's in there.
Yeah.
So you sort of get creative liberty in some sense. You can just do whatever you want inside the black hole. And not only do we not know what's in there, you know, the physics says that we can never know what's in there. That's the other thing. We're not allowed to know what's in there by definition, because light can't get out, and if light can't get out, information can't get out. So that's the whole problem.
Unless science...
The idea of that was that they in that movie was they put the probe into the black hole and sent the data back before it was untransmissible.
Something like that,
Yeah.
And that also created some teleporting and whatnot.
And that solved the mystery that they were trying to figure out.
That's fine, because that doesn't break any rules that we currently have, because we don't have any rules inside of a black hole. That's why I thought that movie was really clever.
Wow.
So what if science figures out that something is coming out, we just haven't figured out what that is yet? Or
that's
we
science.
haven't...
And that's science.
So there could be something coming out of a black hole, but we don't have the tools to record it.
That's right. Yep.
Or it could be...
Or to travel there, or to... to monitor it. Exactly.
Wow. Fucking hell. So...
It's mind-bending.
It took you 7 years to do this.
That's right, yeah.
And now that you're a young doctor... You're a professor as well?
No way. No, that's
What's
like
that?
That's like 20 years from now.
Okay.
Professor is like the peak of academic. It's like boss of boss, CEO of science, right? So I'm what I'd call a research associate, a postdoctorate. And that's sort of like the first time you can call yourself an astrophysicist and get paid a real salary.
Yeah.
But you're still very much at the bottom.
Right? Who pays you? Like the government?
So it depends, right? Depends on which country you work as an astrophysicist in.
Do you have allegiances?
Talk about those.
So countries can hire you to work for them.
In Australia, it's done through universities. Universities get paid through either governments or their own kind of grant systems, and then
is it well funded?
Australia is one of the best places to do science, and astrophysics in general.
Yeah.
Australia is genuinely one of the best places to do it, and it's because look, we don't hear about this much, but we kind of do care about science in some roundabout way, and I know that the government, stifles a lot of the funding that goes into science. But at the end of the day, scientists aren't just treated as like, people just kind of sitting around thinking about things. Yeah, there's outputs that come from science, right? And a lot of astrophysics has these outputs that we wouldn't have, thought that this is what we would have used for it. Like GPS, Wi-Fi, all these things came out of astrophysics.
Wow.
But we didn't know that was our plan, right? So it's all this offshoot technology that comes out of research that you don't plan to discover, but it does come about. And so if you...
That's what they tell us, right, Delby? We know it was reversed engineered technology.
Sorry, we knew the conclusion. We're just trying to get there and get some money on the way.
And as a young doctor, if you come up with a theory, do the old dogs try to shout you down? Are they very stagmatic in how they were?
There's camps, right? There's camps where people have this sort of mindset that's locked in, and they won't.
But
move
as a
from
scientist, shouldn't you be?
Yeah, but we're all human at the end of the day,
so
right?
Ego is a big thing.
Yeah, ego. Allegiances. It comes into everything.
Because surely, like in my head, the idea of following an idea and a concept and having my world shattered would be exciting. It'd be like, fuck, everything we thought we knew was wrong. Yeah. And it'd be like, right, now we can move into these new spaces instead of like, sometimes you see these people like, and I don't know what it's like in your field, but they won't change.
Yeah, that's right.
And I'm sure it happens in your field.
It does, for sure. They won't change. But the exciting stuff, as you said, is when we break through those kind of assumptions that we had and realize, oh shit, we were wrong this whole time.
Yeah.
all right, that sucks, but cool, let's move on. Let's learn some stuff.
Use this new knowledge to go, right, that opens up this avenue and this avenue and this avenue.
That's the exciting part of science, I think.
So becoming a doctor, you have to do a doctorate?
Yeah.
Did you have to pick a subject that you wanted to do, like a thesis or something?
That's what a doctorate is. It's like one it's like a narrow part of a narrow part of a narrow part of a field, right? So for me, it was astronomy as my field.
Yep.
Then galaxies is the narrow part of my field of astronomy, and then within galaxies,
the narrow part is just galaxies.
Right, yeah. Well, like there's stars, there's planets, there's moon. Space is so big, right? And then my narrow part of that was understanding the structures of galaxies, so the shapes of galaxies.
So that excites you?
That's my thesis. Not anymore because I did it for 3 years and I'm kind of sick of it.
So because galaxies are generally they're different to nebula, is it? So that's nebula.
That's a nebula within a galaxy. So nebulas sit within galaxies.
Okay.
What the fuck is a nebula?
Nebula are where stars form, right? So we formed our star formed inside of a nebula. Nebula are gas pockets where like it's really dense amount of gases here, and they're kind of starting to form stars.
Yep.
This is this idea of brothers and sisters. Stars form
that's
in
a
stellar
nebula.
That's a nebula, yeah.
Okay.
And there's lots of nebula inside of a galaxy, and over time, those nebula form more stars, and those stars form this structure that is a galaxy.
And for example, the pillars of creation,
it's one nebula.
It's just one.
Not even a special nebula, as far as I'm concerned.
Just looks
millions
cool.
of these nebula. It does look cool because it's kind of this one.
Okay.
Yeah.
There's this nebula. I don't know the name of it now, but it's like genuinely looks like just a
road finger.
Really?
It's so good.
The fuck you nebula.
I think it's called the Defiant Nebula. It's honestly iconically like a.
Or if it was scientists, it'd just be the middle finger nebula.
And so that's just a small part of a galaxy.
That's it, our galaxy.
And that's where the stars are forming within those nebula.
That's right. So there's all these levels to it, obviously.
So where, and I just keep using that one because that's one of the only nebulas I really know. But where would that be? What part of what galaxy is that one located?
That's in our galaxy, and it's actually really.
It's in our own galaxy, in the Milky Way.
In the Milky Way galaxy, right?
Oh, wow.
The reason it looks so detailed is because it's so close to us, right?
Yeah.
It's really, it's one of our closest nebula.
Or maybe it was just a good artist.
Yeah, that's it. Just went
that fucking
like on the dome that's covering the Earth.
Yeah,
just like painted on there.
Yeah. Or whoever was interpreting the results was like, I'm going to make this look cool.
Right.
Oh,
fuck.
That's it. Why do you think COVID's been happening over the last 2 years? They had to change all the batteries and all the birds.
Oh, you've heard that conspiracy? That birds are fake?
What do you mean conspiracy?
Actually, in saying that on conspiracies, flat Earth, is there a way that you can just like scientifically just go bang, this is why you are wrong?
So solar eclipses, right? Because if the Earth was flat, its shadow on the moon, right, would be a flat disk, right? But it's not. It's a circle. So there's going to be a lunar eclipse in like a few months from now, maybe like a month or two.
Yeah.
Look at it. If you see a thin line across it, then your Earth is flat.
Oh,
If it's a circle, the Earth is round, right? It's as simple as that. The Greeks knew this like 2,000 years ago. It's not even a conspiracy anymore.
Because if we were flat, the shadow that it would cast, when it directly lines up, would be a thin line.
Yeah.
But what if it's just a big fucking flat disc and it's filling it up?
But it forms a curve. It forms a circle on the moon, right? It's a circular shape.
So you'd have to be a cylinder.
So, or the lamp that they're using, right, inside the dome. Put a little
Truman
dot
Show.
there. Yeah, Truman Show-esque, right?
Or the moon isn't even real, and they just put a fake.
Yeah.
There's a comic over
Maybe
in
a simulation.
There's an Irish comic. I forgot his name. That I met in Edinburgh, and he's like, he goes, the moon's real. He goes, the moon. You believe in the moon? Birds are charging. And you just if somebody tells him a conspiracy theory, he just comes at him with a harder one.
Yeah.
That's it.
Like,
that's what you got to do with
birds on power
theories.
lines. They're charging.
That's
You've
like
got to one up them always, right?
that's like what Jehmal did in the street the other
week
when he was asked if he believes in abortion. He said, "I don't even believe we're real."
How do you contest that?
He just fucking walked away.
It's the ultimate defense to any argument, right?
Well, what's the biggest misconception, though, since we're talking about conspiracies and that? Biggest misconception or fake news that you hear about astrophysics or stuff that you have to prove wrong all the time?
Or it's got to be the moon landing. It's got to be, right? It happens
right.
quite a bit.
What do you think?
Either way, I don't care because we're going to land on it soon anyway, right? So in a few years' time...
Yeah, we're going back, aren't we?
Yeah, we're going back, right? Or we're going for the first time.
Yeah.
Depends on what you think. But here's my one bit of evidence, because I could tell you all about the cameras that they used and the video stuff and all the footage that there is. But there's one answer that I always give for this, why I think it is real, and it's the Russians, right? At no point has any Russian official, Roscosmos, that's the sort of NASA equivalent in Russia, ever claimed that NASA didn't go to the moon, right? But they poured millions, billions of dollars into trying to figure that out, right? And to beat them for one, and then also after the fact to prove that it did or did not happen. Yeah, they wanted to be, absolutely sure, because if they didn't do it, then that was their chance to do it first, right? This is arms race of getting to the moon. Not once have they ever claimed that NASA hasn't gone on to the moon. So if the Russians haven't claimed it, either you have to then believe that the Russians and the US are,
in cahoots,
which then that's another crazy idea altogether, right? Yeah. You have to. If you believe that, you'll believe anything, right? So
World War II they got together,
or the less surprising thing I think is that we actually did land on the moon.
But it's insane, man. 1969.
That's right.
1969.
I know.
They're fucking walking on the moon, sending back images and footage. Bro, when it rains, I can't get Foxtel.
Yeah.
What the fuck?
This is my theory on the moon, just a complete theory. I think we went. I just don't think the film and footage was false.
Yeah, there's lots of.
That's all.
You can find infinite videos on diagnosing the videos and whether they were real or not, or blah blah blah. For the most part, a lot of the original footage was lost anyway because it was on magnetic tape, right? This is old school way of filming, and that has a shelf life, right? So a lot of it was lost and destroyed and blah blah blah, and it's expired over time. So a lot of the original footage actually doesn't even exist anymore. So yeah, there's probably been lots of this fake footage that's been injected into media.
That's exactly what I felt. They've just gone, fuck.
What about the moon rock that they gave that was just fossilized log? That's pretty dodgy.
But
the other thing is that one?
Yeah. I mean, and there's infinite things that you could kind of give as examples for why not.
It's a bit weird and dodgy, but I think we went, just didn't. It's not the full story.
If they did go, they are fucking the bravest people of all time. Knowing you're about to step out of, first of all, out of a rocket, where you're in the middle of the fucking space anyway, and then you don't know if you're just going to shoot off.
Yeah, because they didn't know anything back in the 60s about the moon. But
they're just hoping that the theory's right when they jump out.
Yeah.
So explain, is it the Kuiper belt?
Yeah.
One more question?
Oh, yeah.
Just hold on to that.
Yeah, it's on this.
Is there a laser on the moon that we can shoot at and it shoots back?
Yes, there's a mirror on the moon. There's a mirror on the moon that they left there, and that's one of the reasons. The easiest way to figure out whether you've actually been there is to shoot a laser in it. If you get the mirror, if you get the light back, then for sure you were there. The other thing that's useful for is, remember I said that the moon's moving away from us at 5 centimeters a year. Yeah. We know that because we left a mirror on the moon, and we can measure that distance, and every year it's 5 centimeters further and further and further.
Wow. Do they measure how long light takes?
Yeah, exactly, because we know exactly how long light takes, so you just got to figure out
light's consistent.
How long that time was, and you divide it through by the speed of light, and there you go, there's a distance.
Is light consistent if it's bending?
Yes, it always travels at the speed of light.
Okay.
Yeah. So as in, it will still, if there was a bend on the way, it would still get here in the same time, just out of interest?
It would it would take longer, because it's travelled a greater distance in the curve.
So maybe there's a bend that we don't. Oh no, you'd see it, wouldn't you?
Yeah, you'd see it.
How big's the mirror?
Meters.
Right.
Meters.
Well, imagine if they forgot to pack it. So when you see the face on the moon, it could just be.
And these sorts of things. That's exactly why I think. We went.
There's stuff
we left it. We just. I think the footage that they've injected, and that's where you get the artifacts that are.
It's probably an accident. They just littered.
Yeah, probably fucked up. Yeah,
that's where we're sending all our recycling in Australia these days.
Yeah.
So Kuiper belt.
Yeah, Kuiper belt. Explain
what is that? What is that?
Okay, so we have the asteroid belt, right, which is this region between Mars and Jupiter where things are kind of gravitationally stable and blah blah blah. The same is true also beyond Pluto and some of the other sort of mini planets that are out there. There's this region where you have lots of material that's sort of over time just kind of deflected into this region. Again, it's in this gravitational stable place. It doesn't want to move away from it. It forms this sort of cloud around the solar system. A lot of people say that's like one of the edges to the solar system. You can go beyond that, but there's then where does the solar system end? Where does the sun's influence on the region around it? Where does it end? And one of the definitions is beyond the Kuiper belt, or in some cases to a place called the Oort cloud. It's even further still.
Oort cloud?
Yeah.
Sounds like a nickname for a butt. Right, yeah, Oort. Surely it ends where light doesn't reach.
Light
or does light
infinitely.
Oh my God. Light travels forever.
And
infinitely.
Really fast.
And so, because I did watch this documentary the other day on infinity.
All right, okay.
And they were talking about even just trying to observe the universe from the outside, the observable universe from the outside, would then be impossible, because if the light is getting there, that's part of the observable universe.
Yeah.
So you can't. It's only a theorized and a mathematical equation of what we know we can collect, because you could never look down upon the universe, because that would be part of the universe itself.
There are parts in the universe that we'll never see because the light takes too long to get from there to us. Right.
What the
And it's only getting further. Is that correct?
Yeah, that's right. It's getting further and further, and the fact that it's further and moving away from us means we'll never see it, because it's moving at a speed that's faster than the light coming back to us. So it's sort of in freeze frame. That's a crazy idea.
So it's moving faster than light?
But it's not something. So it can break the rules of physics in this case, because it's not a physical object moving faster. It's space itself.
Space is moving.
So
expanding that fast.
Correct me, because I'll definitely get a bit of this wrong. We are expanding on the outer reaches faster than the speed of light, so then the speed of light can't get back past.
That's right.
Yeah.
It'll never get to us because the space itself.
Who created this shit?
God.
Yeah. That's what we've been talking about this whole time. It was God.
And then, so are we in a limited point in which there's certain galaxies close to us, because they're expanding further away from us as well, that every moment that we spend trying to not reach them makes it harder and harder.
Yeah,
to
it
get
will.
to
I
them.
mean, on the local scale, we've got Andromeda, which is our closest galaxy to us. That's actually heading towards us. Actually going to collide with Andromeda at some point.
Oh, wow.
Yeah, so it's going to be what we call a major merger, where two galaxies sort of...
Donald Trump again.
Major merger. Again, astronomy, if it's like a merger of two
major
things...
But it's so easy. That's why people like Donald Trump. He's just going
it's simple.
It's super easy.
Yeah. We need to merge majorly.
That's it.
Fuck. So is anything going to happen when we merge, or I don't know?
Yeah, I mean, we've seen...
Shit's going to
Yeah, it's crazy. You look at some of these merger images of galaxies colliding, and things are shredded and being ripped into pieces, and the galaxies itself will not look like what they once looked like. The crazy part is, right, that no two stars remember these galaxies have 300 billion stars. No two stars will collide, most likely, because there's so much space between the stars. Like us in the next star over 4 light years worth of space, and there's not really that much. We're not really that big. That no two stars would actually collide as these things merge together, right? It's not a collision, it's a merger, a major merger.
Major merger.
So would there be more busy parts of a galaxy?
We
for
get
example,
fucked.
aren't we moving into at this stage, a more busy part of our own galaxy?
Yeah, so we're always constantly moving through different parts of space.
Yeah.
And for sure we're moving towards the denser parts of space at any given time. But yeah, when this happens, things will be shredded. The planet won't stay around the sun anymore. It'd be chaos. We're dead for sure.
Yeah, wow. And then I see that we actually did we see 2 black holes merge?
Oh, this
recently?
is gravitational waves. This is huge. So this is what Einstein predicted again, right? Hundreds of years ago, 100 years ago, that if you have 2 massive objects merge with one another, they'll send out a wave in gravity throughout space, right? And this is you have to think of it like if you drop something into a pond, it sends out a ripple.
Yep.
That's what's happening when these two things merge. They send out this ripple of space fluctuating up and down, bending, getting thick, stretched and compressed through the universe. It passes through the Earth. The entire Earth stretches. This is not a joke. This is actually what happens by tiniest fraction of a proton's width, so a tiny amount. You'd never notice it, but it is happening.
But measurable.
How did they measure it?
Lasers, man. Lasers is the solution.
Freaking lasers. What do you mean?
So same idea with the moon, right? We send a laser to the moon, it hits a mirror, it comes back.
Yeah.
And we know that distance exactly. If you do the same thing on Earth, but really, really far, you see how far that distance is, and if it's stable, all good, and then all of a sudden it gets shorter, and then it gets longer, and then it gets shorter and longer and longer. And it's the same pattern that you would see if 2 black holes merged. So it's the fact that you saw this laser change by a fraction of amount, right? The distance between the laser, the 2 mirrors, by a fraction of amount, but the exact same pattern that was predicted by the theory of general relativity that Einstein put out.
What the fuck?
So in the same way that you turn the data into a color for a picture, can you turn it into sound?
Yeah, so with black holes, that's exactly what you do. You get this kind of chirp effect. Because if you think about what sound is, it's just vibrations, right? And compression and refraction, which is the stretching of those waves. That's what's making the sound. And so you can turn it into a chirp noise, which is where it kind of goes up in frequency, where it gets to, it's really like the point where the two black holes collide. And that's where you have the highest kind of pitch, the highest frequency of those gravitational waves getting sent out. And that sound is exactly predicted by Einstein's theory. He has a mathematical equation that lays it out, right? And then you look at the data and you compare the two and they're identical. So
what a fucking freak, man.
Right? How did he do this? And he didn't, like
he
you said,
he wore the same clothes every day. He didn't have to think about it. Did you know all that stuff?
No.
Like he used to rid himself of choices so he could focus his everything on, so he wouldn't wear
What did you
clothes.
say, Jamal? Schizophrenic as
Yeah.
well? You'd
So
have to be.
So he'd wake up in the same, every morning, have the same breakfast, same clothes, same everything. So he wouldn't have to make choices and decisions, so he could focus his full attention on his craft. He'd have
That's
like
just fucking dumb.
Was he also the one who had
Must conserve brain space.
Yeah. Was he also the one who I feel like he
Sounds a bit
he had
autistic,
little
to be
naps?
honest.
Or was that, am I thinking of someone else?
couldn't tell
Newton
you.
or someone would have naps.
Yeah, Newton had a nap under an apple tree.
There was someone who
that's what it was.
there was someone who had naps and they'd put himself on a rocking chair and to a point because they reckoned
Thomas Edison, I think.
just at the point of it might have been, and just at the point of where they'd
The
reached
lucid point.
yeah, the alpha brainwave or the or the delta, and it would fall and it would drop something off the rocking chair and it would wake him up and he'd get back up and he'd start theorizing more.
Amazing.
I can't remember who that was.
The original alpha brain.
Yeah. Mate, I'm gonna go with that alpha brain stuff that Rogan.
Yeah.
Stuff. I just want to talk about that very quickly.
Yeah.
Just gives me headaches.
Yeah, gave me a headache because it's a neuro.
Is it because I've never operated that well?
Nah, because it's what's the word for chemical that affect your brain?
The neural path.
Neurochemical. Yeah.
A neurochemical, but it's also.
We have neurons firing. You've electrical charge between
Pathways.
No, there's another word for it. It's like not a nutrigen and
Nootropic.
nootropic. Yeah. So
So
I think
I should have had my my alpha brain today.
I think that's I've had my alpha dexies.
Yeah.
I think that's what's happening is that maybe your brain hasn't it's overloading those.
Yeah, that's how
that
it
part.
felt. It felt like every time I had it, like I could concentrate, I could get a lot more done. But fuck, I just had this. Towards the end, I'd have this really bad headache, and it would it'd make it worse. If anything,
Probably.
I just want to lie down and do nothing.
Well, I mean, humans probably didn't evolve to have that happen.
Yeah.
To us, right? So you start to put them in there.
So I don't have alpha brain anymore.
Yeah.
But
So this laser that was
Yeah.
there to measure gravitational, were they just hoping that two black holes collide somewhere and we're picking it up?
Well, we think there's so many black holes in the universe that this is happening constantly.
Right.
And because it's like this thing that kind of transmit all throughout space, at some point one's going to hit the Earth. And in fact, they've discovered like hundreds of these things now.
Okay.
It's not even news anymore.
How quickly after they created the laser to point whatever the measuring instrument was, did they discover it? Immediately?
It's like years. Like
Oh,
in a
wow.
year or two, which is pretty impressive because they, these things are like kilometers of tunnel that's completely vacuum sealed, that's like soundproofed and everything, that huge technology advanced to make these things, right? But then they turn it on in a year and they start discovering hundreds of these black hole mergers.
So would it have been this? I guess this idea that they had seen this black hole and that black hole through the bending light and the matter around them and realized they were on a path towards each other, or was it literally just
serendipitous? You
because
don't
of
actually
infinite?
know that they're there because of infinite, probably.
Yeah.
No, because you don't know they're there because you can't see them. So you just see the effect of them, and then you try to figure out, okay, where did they come from? Where did that signal come from? That's the really hard part, is to figure out where those merging black holes came from, which we don't actually know. We just know that they came from somewhere in this patch of the sky.
Mate, imagine going to work every day. Nah, didn't happen. Nah,
Sorry, boys.
going
Go
home.
home.
Year later.
Tools down.
Yee. I remember when that happened. That was massive.
Yeah,
That
it
was
was huge.
what's the most recent astrophysics ground changing discovery? Was that the most recent game changer?
Yeah, I'd say the discovery of colliding black holes,
Yeah.
because it opens up another dimension in the way we observe the universe. Like we talk about optical light, we talk about infrared light, ultraviolet light. That's all electromagnetic. This is like on a spectrum, right? This is like all the continuous forms of one part of the spectrum, and that's light, right? Now all of a sudden you've got gravitational waves, which is a completely different dimension to look at the universe through. So that's opened up this, and we don't have a use for it yet, right?
Yeah.
But again, like I said,
We'll figure it out.
most of the time when we're looking out at things, we don't know what the uses are going to be. So it's really kind of exciting to see what's going to come out of looking at the universe through a completely different lens than just light.
How do you
alone.
look at it through a gravitational wave?
Yeah, I mean, I don't know.
We don't know yet?
We don't know. We don't know what the use of that is. All that we know is that in astronomy, all we've ever done is looked at things with light. That's all we can do. Because we can't go out there and, hold up a ruler. Yeah. We can't put things on scales. So we have to use light. That's the only thing we have as an option to do astronomy. So all of a sudden, we've got something else. Right? And that's what's exciting.
Is that how is that how we discovered the first black hole, looking at a star and then just seeing a bend?
It's the bending. It's the bending that kind of gave away the fact that you could see these black holes. And you can see simulations of these things and actually sometimes images of what it looks like to have that bending effect. And actually Interstellar showed the bending of the black hole. And it wasn't like, oh, look at this artist impression. They got in an astronomer, an astrophysicist.
Oh, wow.
Right? And they said, what would this actually look like? And then they ran computer simulations of what this would look like. And they projected that. And that image of the black hole that's shown in Interstellar is probably the best rendition, scientifically accurate rendition of a black hole that we've ever seen.
I'm going to watch Interstellar again after this. I'm going to watch it.
It'll blow your mind.
Yeah, when was the last time you watched it?
Ages ago.
Mate,
and it doesn't get easier to understand.
When they go
I watched it next week.
when they go to the construct, the fifth dimensional thing that they construct for them to understand fifth dimensional reasoning in a three-dimensional world, it was like that started just blowing my mind.
Yeah.
It was fucking well written, everything.
It's well done. Yeah, it's good. It's a great movie.
Yeah. I've got a request. Well, not a request, but actually, it is a request. So, Fish, if you're listening, this is for you. He's always like, get someone on that can talk about the Hadron Collider. How much do you know about the Hadron Collider?
Does it very little?
Very little. Okay.
And that's because it's on Earth, and I only care about things that are off Earth. That's my blanket statement. I know that it's in Switzerland.
Yeah.
They collide very massive, very small particles.
Yeah.
At
I know
speed.
it's kilometers long, and they're trying to shoot protons at each other to split them up, right?
How do you do that?
Very carefully.
Do you know how they shoot it or speed something up?
It's probably magnets. Let's be honest.
Oh, yeah.
It's probably no. So look, you've got to get these things to a certain speed, but you've got to do it over a winding effect, because if you don't have a tube, then as soon as you speed something up, it just you're sending it off to nowhere. You need to get it in this kind of ring pattern, and then you have particles going one way and particles go the other way, and then you open up the tunnels and you have them collide in at a very fast rate.
I can't believe somebody just was like, yeah, let's do it, and see what happens.
Yeah,
because if that created a black hole, we all could have fucking.
That was the fear, wasn't there? There was a lot of pushback. A lot of people didn't want it because they were
a few naysayers.
Yeah. Do it somewhere else.
Fearful of the unknown.
Do it out in space.
Who knows? Who's to say that didn't create a new timeline?
Mandela effect is legit.
All right, yeah.
Are you across this?
It's like people kind of sheepishly come onto an idea and then stick to it. Is that it?
No. Mandela effect is when you remember two things differently. So some people remember Mandela dying in prison, and some people remember him being freed.
Yeah, yes. And some people remember Shazam being Shaquille O'Neal. Some people remember it being.
I remember it was Shaq. Who was it?
I remember it being Shaq.
Yeah.
But
so there's all these things.
A lot of people think it was this other actor.
Yeah.
The real question is, was the dress white and gold, or was it black and gold? That's what we want to know.
As an astrophysicist,
so
it depends on the light, right?
It does.
Like, I never understood that.
Yeah.
I remember seeing an explanation for it, but it's all to do with, it's actually all in the brain, right? It's our brain's way of taking shortcuts and seeing things, right? So if you're the kind of person that saw that dress inside of a room with neon lights or fake LED lights, then your brain would be like, okay, in that case, if it's not natural lighting, then it must be black and blue. But if you're someone who saw it in the outside, you've got natural glow, then you would see it as, you take the shortcut in your brain and see it as white and gold.
Okay.
I could change, which was...
Could you do that?
Yeah.
Because not everyone could. It's kind of like that spinning
the ballerina.
Yeah, if you can do that, that's
retrograde it.
Yeah, retrograde that shit.
There were moments where I'd be like, I can't change. And then there were moments where I could do it on call. So I don't know what was going on in my head.
You're obviously in your alpha state at that point. Yeah.
I just on my rocking chair.
That's right.
Fuck, I can't believe they just were like, let's smash them together and see what happens.
Yeah, that's it. Because they didn't know, right? And this is where the quantum came in, right? Because what's below the proton, if you smash it together, what is it made up of? And that's where we discovered quarks and all these other crazy...
God particle, Higgs boson.
Yes,
so
exactly.
the Higgs boson we discovered because of that. And
that's right. Yeah.
ends
it
up...
was theorized, and then that proved it, right?
Again, that's this idea where we theorize a lot of things. Some of them are correct, right?
Yeah.
And some of them are not correct. And it's the things that are correct that are obviously interesting.
Yeah. Okay.
I think a lot of people and a lot of journalists and a lot of everyone could use the scientific method of come up with a theory and then try and prove it wrong.
Yeah.
That's it.
Instead of trying to prove it right.
I could say you're a lizard person.
Yeah.
And I'm right until I prove it wrong.
Prove me wrong.
Prove me wrong.
I'd have to tear your fucking head off.
Well, I was right.
Oops.
What gets you going? What's your favourite part now?
Of astronomy? Yeah. It's surprisingly less to do with what I do on a day-to-day and more just the talking to people and
like this.
Yeah, like honestly, I love this stuff because
I've
for an astronomer,
so much.
yeah, that's the thing because like the first time you do it, it's awesome. You learn all this stuff. It's awesome.
Yeah.
It's cool. But then you do a degree in it, and I'm not going to say you've learned everything, but you've gone through a lot of it. So you want that second-hand experience of like teaching someone all this amazing stuff and
seeing the vein.
Exactly, getting the vein popping and everything, right?
Fuck.
To get that second-hand like excitement over science is really cool. So that's why I enjoyed doing it.
So what about you did say in your email that there's a lot of pressure to write journal articles within the community. Are you expected to be working on shit all the time, or what's the time?
Yeah, that's it. Yeah, multiple papers per year.
Really?
For a person of my kind of career level, yeah, for sure.
Right.
And if you're not doing that, you're really cutting down your prospects of getting the next job and the next job because these contracts we get are like at best 3-year contracts, right?
Yeah.
The current one I'm on 3 years. So what am I going to do in a year from now? Who knows, right?
Yeah, right.
It's genuinely a matter of that. And because it is a niche field, right? Astrophysics is itself. There's not many of us in the world.
Yeah.
So there's less places for it and there's a lot of competition for it. So you've really got to be a cut above.
Yeah.
And the way, unfortunately, we like rank people is how many papers that they publish.
It's fucked.
It is a bit fucked. And like it means that people who do other kind of contributions to the field, like myself, I feel like I do a lot of work in outreach and like, getting in touch with the public and kind of projecting
important stuff.
I think I would think the important stuff, but that's not really seen at the academic level, right?
Yeah.
And that's fine, I guess, but it does definitely breed this culture of like the only way to get forward is to publish.
And are they just publishing shit?
And that's what can happen, right?
Yeah.
That's what can happen. And what you get are these papers that are like, okay, look, we did this survey of a bunch of galaxies, and they write a paper per galaxy, which is just not interesting, and no one's going to read it. But look at all these papers I've published in the last year, right? So it does breed these sort of bad cultures around.
It's like the reality TV of academia.
Yeah, it is. It's
putting out all this trash.
Efficient.
That doesn't mean anything.
That's right. Big catchy headlines,
yeah.
Right? But nothing that's meaningful. So that's, in some ways it's good and in some ways it's bad. And this is sort of the bad parts of astronomy.
What are you currently working on?
Lots of things. So I'm working a lot with the James Webb Space Telescope data, trying to make that from the shitty data that it looks like to begin with to nice, beautiful images that we can work with scientifically.
And where does that take place here? Because this is in Perth?
Yeah, this is in Perth. So we have a thing, this is amazing, in Western Australia called the International Centre for Radio Astronomy Research, which hires like 300-ish astronomers, engineers, data scientists, etc. across Curtin University and UWA, and this is where I work. And so this is like one of the biggest research institutes in Australia and also around the world doing incredible science, incredible research, and building the biggest telescope on the Earth currently. So we're building this thing called the Square Kilometre Array. So as the name suggests, it's a square kilometre of telescopes, right? It's massive, or will be.
Of lots of telescopes?
Lots of telescopes, yes. And this is the thing, right? You try, bigger is better in astronomy, not also just astronomy, but, in general, right? But the bigger the telescope, the better. But at some point, you build a telescope so big, it starts to curve under its own weight or it breaks, et cetera, et cetera. It's a limit. So what you do is you build lots of little ones and you space them out over the area of the size of a telescope that you would want. And all you've got is a bunch of holes in between your telescope, but that's all right. We fix that in post, right? That's the idea.
Wow.
That's the concept of these arrays. And this is this new sort of engineering sort of tactic for building big telescopes. And we're building one out in the middle of nowhere, actually, in Murchison.
So this will be a ground Earth-based
It's an Earth-based one. And so actually a radio telescope. So we talk about optical light, and there's the infrared, there's microwave, and then there's the radio. This is the really, really far wavelengths.
Okay. Is that is that shitter?
Yeah, it is. It looks shit.
Yeah.
but like it looks at cool science. So when I say it looks shit, the resolution is crap, right? Because it's these long wavelengths of light. It doesn't look like these really beautiful images that you see.
So what are you getting back? On a piece of paper, it's just waves, and you turn that into an image.
That's honestly one of the best descriptions I've heard of radio astronomy. Yeah, you're getting signals coming in, but it goes through a computer, and then you process it, you collect those signals together, and then you form an image after the fact.
That's so
three-dimensionally
fucking
or
insane.
two-dimensional?
Three-dimensionally, which is the crazy part about it. You not only get the image, you also get the depth. You get the depth of these things. So you can start making these three-dimensional observations of things, right? And that's the cool part.
And it's 100% accurate.
No, it's like 50% accurate. I don't know. The thing is, like, it's hard. This is a hard thing to do. And so, you've got to put a lot of work into just getting something that's a baseline measurement of something.
So this could be not real.
That's real. I think that's real. That's a nebula.
But
That's a real nebula. But it's a two-dimensional nebula, right? You point a radio telescope at that, and you can all of a sudden get the depth in this.
And is that how you read the observable universe, through radio waves?
We can. That's one way of doing it, right? And the great thing about radio waves is they don't get blocked by dust and other crappy things that are out in the universe. The wavelengths are so long, they don't even care about little particles and whatever. They just go straight through them, right? So the radio waves are really like good at penetrating far into the universe. So we think we're going to use the square kilometer array to look at the very, very, very beginnings of the universe, the very most distant.
Probably just God on his rocking chair.
What is
got me?
So his robe back on. Like,
so if it's expanding,
carpet belt on.
We must know ish where the center is.
No, we don't. Well, I mean, look, you can make a prediction if you like reverse time, right, and see where everything's going inwards.
Yes.
You could be like, okay, that's where it probably is. But the problem is when you're inside the expanding universe, trying to figure out where everything's expanding from. There's no way of knowing.
It's relative to where we are.
If you were outside of the universe and you saw where everything was, then you'd be like, there's the middle.
But you can't be outside the universe because then you're still in the universe.
Bingo. It comes back to that observational thing.
That
the omnipotent observer, right? We are not that. We're inside of our own universe.
So we can't even find where the center is.
No.
It's like me trying to find the G spot.
You know, it's somewhere in this region, but
if it exists at all.
Do we have a general idea?
That's the thing. I think we know generally where the center
is.
That's
the God spot in this case.
The God spot. And what do we? I guess we assume there's
nothing special about
massive black hole in the middle.
No, I think the thing is there's nothing special about space when you zoom out too far, right? Everything just looks the same. It's homogeneous, right? Yeah. Everything looks exactly the same at some point.
Yeah. Because it's so far.
It's so far that even like blips that are galaxies are just blurred out.
Yeah.
And when you said Big Bang wasn't big
or bang
or a bang,
in
the middle,
it's a better name for it would be the everywhere stretch.
I think I know her.
Okay, explain the everywhere stretch.
Because there's nothing. A bang implies there's an explosion, like combustion happening, but there's nothing of that. It's just the space around us began to expand. Well, around us, I mean everything that was the universe began to expand, and it expanded everywhere at the same time, not from a centralized point. Right? Explosion implies that. Or bang implies that there was a center point and everything exploded into that region. Actually, no, it's the entire space itself expanding.
That is hell. That is fucking with my head because it's expanding into something that wasn't there before. But if it's not there, it has to be there because it's expanded into it.
Yeah.
What the fuck, man?
So is that why this idea of
the
never-ending contracted?
Yeah, exactly.
Makes
stretch and contract
similar to the sense. Instead of it being the explosion, it's the point at which it actually reaches the center point and then re-expands back out.
That's it. And that's why that's a better name, right?
We are in a fucking simulation.
Okay, so what is it? Not the Big Bang, it's the
everywhere stretch.
The everywhere stretch.
Yeah.
Oh.
It's like me on a bender. I'm just fucking stretching out everything.
That is the clip.
There's two veins.
It hurts my fucking brain, man. We have to be in a simulation.
Yeah.
Because
probably.
To conceptualize our universe, and if it is expanding, then it's going out into something that doesn't fucking exist.
But doesn't it seem more possible that because it's so unexplainable and so randomly stupid almost, that it's not by design and it is just a random occurrence?
Could be. And this is where the God of the Gaps comes in. It's not God of the Gaps anymore. It's simulation of the gaps. This is when I think
that's a Kim Kardashian porn.
Simulation of the gaps. Yeah, I think we turn to simulation now as like it's a bit of a culture thing to say, oh no, we're probably living in a simulation because I don't understand this.
Yeah.
It's probably because it's simulated.
I just feel like it is just so...
God was cool like 200 years ago. Now simulations are cool.
Everything is just so improbable and so almost just random that it can't be almost by design, even though I do have that inner thought that I feel like God, for lack of a better word, source energy is well, I'll call it, is probably the beginning of it all. But that's again, it's just a third dimensional name for what is really. Yeah. That's what I guess.
It really fucks with your head when you think about the size or the concept of nothingness.
Yeah. Do you have to stop yourself from thinking about these sorts of things?
I have to think about this every single day, so it's like constantly on my mind.
Well, I was going to say, when you're having that sort of enormity going on in your head, does it become a point where you're just like,
I'm going to wear the same thing, eat the same food?
That's right.
Yeah, do you just go, I just need to I'm just going to go have a beer on the beach. I
definitely enjoy a beer on the beach, but I think you just get numb to it all, hey?
Yeah.
I think you just everything gets so normal in comparison.
Yeah.
You don't even think about the numbers anymore as numbers. You know, you're just sort of, Yeah.
Just have to accept it.
Just accept it and you move on.
Because there's a sense of feeling that astronauts get when they see the Earth from the outside. What's that called?
Yeah, I know it. I don't
the
know.
great view.
But they come
the very far view away.
Yeah, so
the
when
away view.
When they come back, they have this feeling of depression and sort of insignificance.
I think because when you're up there in space, right, you don't have to deal with the stupid shit that happens on this planet, right?
Yeah.
Right? You're up there, you're away from that stuff. All you're dealing with is your day-to-day, and that day-to-day happens to be looking at your entire planet, which is pretty incredible, right? So then you come back to the shit that happens on the ground here, and you're like, well, this sucks.
Yeah.
Yeah, you'd be looking back at it like this is just
nothing compares.
a spot.
Yeah.
I think everyone should go to space to create world peace.
Yeah.
Just to look back and go, that's us.
Yeah, it's
not these different countries and fucking.
I reckon that would be the case. Yeah.
And hearing I can't remember which astronaut was it, but hearing them talk about when you look at it, it's literally just a ball floating in.
Or a disc.
A disc.
Or a disc on the top.
A big rock floating in space, like just there.
Yeah.
And that's where you sort of you put yourself as this is your home base. This is where you base everything. But it could just be could just float away.
That's it.
That must be such a.
It's a head fuck.
Oh,
it is.
The feeling of insignificance, but
fuck, man.
We've been going for how long? About hour 40. Did you have any other questions?
I did. It was something.
There's so
to do
many
with,
more that.
The type of people that you work with, is it a varied type, or do you typically get very similar, like stereotypes of people? And are there many women in the industry?
That's a big thing, right? Like, obviously it's a male-dominated industry to begin with. It was for the longest time. Science in general was seen as just something that only the men could do. And
it still is, but
yeah, yeah, right. And I mean, like we're working hard to force against that, right? Because it's obviously not the case, right? So
just joking, listeners. Obviously,
don't know why Daniel's giving me a wink over here. That mean to me?
Oh fuck.
Yeah, no. These days it's getting much better. Like the ratios are getting more even. We're seeing just as many women come into
now. Scientists are actually learning skills, social skills.
We're actually able to do more things at the same time. This multitasking idea is like. So much more productive.
And are you one of the youngest in the field?
As I said, I'm probably one of the youngest people to become an astrophysicist. It's the shortest amount of time it could take to do that. So it takes about 7 years. Yeah. From early university to doctorate.
Yeah. Unless you get a wormhole in it.
And so this work that you're doing with the new telescope, what is that leading towards, and what are we trying to achieve, and what's exciting you the most?
Good way to wrap up.
Yeah, that's it. Well, I mean, look, the things that I could list off the top of my head would be cool, right? But it's what I'm excited about are the things we don't even know that we're going to discover with this telescope, right? Yeah. That's again this whole idea of the things we don't know that we don't know, right? Yeah. So, and look, me personally, I want to look at what the early universe looks like, because for the longest time,
Midland.
Yeah, there's still sticks and stones.
Yeah.
So what, the James Webb's going to help you look at early universe?
That's the thing. It's like so much bigger, so much more powerful. It can look further into the universe, pretty much to the kind of early beginnings of the universe, where the first oxygen, carbon atoms were forming, that kind of stuff. That's what we want to look at. We've never seen this before.
But
that's pretty exciting.
Doesn't that? So we talk about like we're looking back at like because the light is traveling, so we are be able to see it.
Historians, right? That's what we do.
So we're looking back in history.
The further back in distance you look, the further back in time you look. And we're getting to that point where we're looking to the very beginnings of the universe.
But how do we...
Can you see dinosaurs?
How do we beat the light there?
It catches up with us.
It catches up. Oh, fuck.
That is pretty fucking insane
turning.
to think.
That's it.
You're literally just looking back.
So you could look at this... You could look at the dawn of the universe.
We call it cosmic dawn, actually. It's funny you should say that. Cosmic dawn.
Because the light wouldn't have got to us yet.
No, it's just appearing, right?
Wait. What do you mean?
Because it's the center, the speed of light. We're further away than the speed of light, so that it would eventually catch.
Yeah, dawn catches up to us.
Yeah.
At some point. And the further you look back in time, the closer you get to that infinite point where light's traveling away, or it's not catching up to us. So we're trying to look to that very point where the edge of the observable universe, we call it the observable universe.
Because the light
can still get to us. It has the chance to still get to us.
It's just behind.
Okay,
so it'd be like
a little bit behind. If you think of it
10 billion years ago or something, yeah.
Wow.
Billions.
Wow. Oh, that's so fucking cool.
And if that doesn't get you to the alpha state, I don't know what will.
Jesus.
Fuck. Oh my God. This has been my favourite episode. I think we've got a regular. We got to get a regular. You're a regular science guy.
Always,
I
anytime.
think that's
Love talking space with you.
Good.
Sick.
Fuck. Is there anything you want to plug while you?
Yeah, any important stuff for people to...
Things are always happening in space.
Yeah.
Oh, do you know what? We should talk about this. The solar eclipse happening next year.
Okay,
cool.
Up in Exmouth. Like, this is a once-in-a-lifetime opportunity. Just happens to be in a beautiful place in the world, in
Yeah.
Blue Reef, right?
Yeah.
I really want to talk about that. That's awesome. See if
Cool.
we can get some people up there.
Oh, sick. Well, Squirrely, our resident, James Hackman.
Ex-Mouthian.
Yeah, he's he lived up there his whole life. So
Yeah, well, he's in for a good show.
When
he
is that?
sold his house though.
Yeah,
we need to find
still
some.
be able to get up
Big
there.
mistake.
What's this?
April 20th.
420. 420.
Hey, maybe we go.
Damn.
420 and what is it? A lunar eclipse? Solar eclipse.
Solar eclipse.
Let's
That
do
means
it like
the
a-
sun's going to go out.
Let's go do a Hard Yarns comedy show up there on the solar eclipse, and then do a little bit of
Well, we
like
better.
a
It's,
bit of
420.
I
content.
think all the accommodation is.
It's fucked. Actually, that's what I want to talk about.
just
It's not
camp.
just like the fact that it's happening, but like how the hell is Exmouth going to deal with this, right? They're
Yeah.
just not going to.
Oh.
Right. I mean, look, their facilities are not going to take
Yeah.
5,000-10,000 people all in
Yeah.
one space.
Let's just camp in the back of a car or something.
And that's what's
Yeah.
going to happen, I think. Yeah.
Yeah. Fuck yeah.
Crazy times.
Right.
Froth Crafts is gonna.
Yeah, we will. Look,
He's gonna love it.
So 420, 2023.
Yeah.
2023 next year.
Okay, cool. We'll see if we can do like a Hard Yarns
Yeah,
road trip.
I like that.
Or we'll get like listeners
Stop in Geraldton or something on the way.
Yeah,
stop
that's
in
it.
like
yeah, the
halfway.
scenic tourist town of Geraldton.
We'll
Yes.
stop in a few on the way. That's a good idea.
Yeah, do a Hard Yarns.
Yeah.
Travelers or
Yeah,
Hard
yeah.
Yarns
On tour.
solar eclipse. Sick.
Anything you want to plug, Delby?
Yeah, so on the universe, doing a Star Wars quiz
Oh, cool.
in 2 Tuesdays.
Yeah.
It's the one I did at Alfred, and all the nerds reckon it was fucking hard, so that's good.
Oh, really?
Star Wars nerds think it's a hard one.
Cool.
I didn't write it. I got a Star Wars nerd to write it. Also doing a Brooklyn Nine-Nine quiz the week after. So come
Where?
check that
I'll
out.
do that.
At Left Bank. All these are at Left Bank in Freo.
I'll come down there.
Cool.
Cool. No doubt.
Branchy, I'll let you plug your run. What do I have? If you're in Mandurah and you want to see me do stand-up, I'm there Friday. Teacher Comedy Night, Planet Royale is back December 21st and big. We didn't even talk about Planet Royale
We'll
on
do
Friday.
it.
Yeah.
Yeah, next week. 'Cause that was great. That was
December
good fun.
23rd. But yeah, everything else. I got fucking heaps and heaps of shows coming up, guys. So
And then Fringe.
yeah.
You're in for a hectic 3 months.
Jump on my Insta, on my link tree. It's got everything there. November 27th is date night. A few Patreons came to that. It's Mickey D's coming back from Adelaide. He's going to be on.
Cool.
Yeah, so heaps happening.
Awesome.
And I'll get you some free tickets as well for coming on.
Absolutely.
So I'm hosting your quiz tonight.
Please.
You
So I
wouldn't have.
can
You
recover.
would, doesn't matter to anyone, I guess. But if you're in Joondalup, I'll be hosting the quiz, and then my run is
Yeah.
this Saturday, 100-kilometer run on Saturday. Again, if you've listened to it next week, it doesn't matter. But if you can get on the Instagram bio and donate, we've reached our target.
Oh, nice.
Raised $2,000, so it could be more
It's
than
going
that.
into the potty or?
It's going towards Zero to Hero mental health charity. So that's going to be good, raising money for suicide prevention. And we've put on our Instagrams, we've got the time breakdown for where we're going to be, and hopefully some people can jump on board. It seems like there's going to be a pretty big crew.
Yeah, cool.
To cheer us over the line. So
Yeah.
me and Stevie Patente running 100 kilometres in a day, and hopefully we finish.
Yeah, fingers crossed.
But yeah, we appreciate all your support for that.
Won't be running at the speed of light.
We definitely won't be
After
running
this
at the speed of
conversation,
light.
I might have to call the suicide prevention hotline.
Yeah,
This has been mind-bending.
Mate, it's been an absolute pleasure having you on,
Cheers,
and you are
mate.
definitely
Thanks,
going to
boys.
come on again.
Fucking awesome.
Cheers.